Ever caught yourself endlessly scrolling through the Apple's website, fantasizing of owning the latest iPhone? Yeah, we've all been there. But have you ever wanted to actually create something as slick as what Apple showcases? Hi there, and welcome to a new video where I'll teach you how to build stunning apps like Apple does for its products. Yes, we'll code an iPhone 15 Pro clone using nothing less than GSAP and Three.js. But we won't just clone the site. We'll start with a detailed crash course on how to create powerful animations using GSAP, after which I'll teach you the core concepts of Three.js and 3D development. And then you'll build the Apple clone website that has custom animations with scroll triggers, staggers, timeline, and more. A custom video slider with progress tracking, animated 3D models with different configurations, lights, and viewports, and other sections with cool animations, complete responsiveness, and optimal performance. We'll go beyond just building and deploy your website to Hostinger's fast servers. But we're not done yet. We'll also use Sentry to track its performance, like how many people visit, how fast it loads, what users are looking at, and see if there are any issues with specific devices. Alongside the video, I've also prepared the ultimate Three.js and GSAP guide that covers a step-by-step roadmap, insider tips, examples, and cool project ideas to take your animation and 3D development skills to the next level. The link to this completely free guide is in the description. So, are you ready to dive in and learn GSAP, Three.js, and then put that expertise to work by cloning the iPhone 15 Pro website? Let's go. Green Socks Animation Platform, often referred to as just GSAP, is a high-performance JavaScript animation library that allows you to effortlessly animate anything JavaScript can touch. You can animate anything, from UIs and SVGs to creating immersive 3D experiences. From exciting scrolling animations to changing shapes of objects, text effects, and UI interactions, there isn't a thing you can't animate with GSAP. Any exciting website you see with animations, parallax effects, or fancy scrolling tricks is likely made with GSAP. From making basic HTML elements move smoothly to creating entire animation timelines, morphing SVGs, customizing bounce and wiggle effects, simulating physics, and more, GSAP is the all-in-one solution for all of your web application animation needs. Gucci, Spotify, Nike, Shopify, and even Google all use GSAP. But there's also Framer Motion, known for its gesture-based interactions, and its declarative syntax, which tightly integrates with React. For simpler animations in React, it's the top choice. Both animation libraries have their own unique use cases. But here's where GSAP takes the throne. GSAP is known for its exceptional performance, even in complex animations. Its optimizations keep the animation smooth, making it the go-to choice for applications in which performance matters. GSAP also offers a high level of flexibility and control over animations, allowing you to create complex sequences, timelines, and effects. GSAP is extensively tested and supported across many browsers and devices, ensuring consistent animations for all users, even on older browsers, and a rich feature set, allowing you to do anything from simple effects to advanced physics-based animations. Now, let's move to the second most important technology in making our apps interactive. It's Three.js, and it'll shape the future of the web with advancements in virtual reality and wider access to more powerful devices. 3D development is just warming up. Before Three.js, creating 3D graphics for the web was a complex task. Web developers had to rely on low-level APIs like WebGL or special plugins like Adobe Flash or Unity, remember those, which were a pain in the ass, with limited browser support and extreme use difficulty. With the growing demand for immersive web experiences and increasing strength of modern browsers, developers needed a better solution for 3D apps. Three.js came in and filled this gap by abstracting away the complexities of WebGL and providing a user-friendly API for building 3D scenes directly in the browser using JavaScript. Some of the key features are the abstraction of WebGL. Three.js abstracts away all WebGL's complexities, providing a higher-level API that simplifies the process of creating and rendering 3D graphics. It has a high cross-platform compatibility, making apps work seamlessly across different devices and browsers. It provides a rich set of tools and utilities for creating immersive 3D experiences, including support for lighting, shading, textures, animations, and interaction. It's also very fast. Using WebGL's hardware-accelerated rendering, Three.js ensures smooth and efficient performance even for complex 3D scenes. And finally, it also has an active community of developers, contributing tutorials, examples, and plugins, making it the go-to choice for developing 3D apps. And starting to learn Three.js is like diving into a new and exciting world, with many features and concepts to learn. To properly learn Three.js, you'll have to move away from the 2D vision and start seeing websites in 3D. In a 3D space, objects possess three-dimensional properties like length, width, and height, or in math, x, y, and z. Unlike the two-dimensional world, which we typically interact with on screens, 3D space adds depth, allowing for a more realistic experience. Each point in a 3D space is represented by a set of coordinates that specify its position from the origin. Now, I want to teach you the most important concepts in 3D development. First is the scene. It's the canvas where all the objects, lights, and cameras are placed, the environment in which the 3D world exists and where interactions happen. Then there's the renderer, which converts the 3D scene into 2D images that can be displayed on the screen. It's responsible for rendering the scene onto the browser. The camera plays an important role in defining the viewpoint from which the scene is viewed. It determines what is visible in the rendered scene. Cameras have properties like position, rotation, and field of view that determine their behavior and how the scene is rendered. Three.js supports different types of cameras with special behaviors, like a perspective camera, which mimics the way human eyes perceive the world, creating a sense of depth and perspective, and an orthographic camera, which renders objects without perspective, which is useful for technical drawings or 2D games. Lights illuminate the scene and affect the appearance of objects. Three.js supports different types of lights, including ambient light, which adds overall illumination to the scene without a specific source, directional light, which emits light from a specific direction, like sunlight, point light, which emits light in all directions from a single point in space, spotlight, which emits light in a cone shape from a specific position and direction. And there are many more. Lights have properties like color, intensity, and position that control their behavior and influence on the scene. So, now that we have the scene, the camera, and the lights, we can finally see some things within the space. And the first thing we can easily show would be a mesh. A mesh is the basic building block of 3D objects in Three.js. It consists of vertices, points in 3D space, connected to form faces. Meshes define the shape and appearance of objects in the scene, and each mesh is associated with a geometry and a material. Geometry defines the structure and shape of a mesh by specifying its vertices, faces, and other attributes. Three.js thankfully provides a wide range of built-in geometries like box geometries, spheres, planes, cylinders, and more. You can also create custom geometries by defining their vertices and faces manually, which will later on allow us to see such a detailed 3D Apple iPhone model. Then there's material. Material determines the appearance of a mesh, including its color, texture, and how it reacts to light. Three.js offers some built-in materials like Mesh Basic Material, which is simple and is not affected by lighting, Mesh Phong Material, which reacts to some light sources, and then the Standard Material, which is a physically based, realistic rendering. And there are many other materials as well, which you can customize by adjusting properties like color, opacity, highlights, and more. And these were all the basic building blocks of Three.js and 3D development. Of course, you can find their detailed instructions alongside a cheat sheet in the guide down below. But Three.js also has some more complicated stuff, like shaders, tweaking with meshes, and animating things around. I'll show you how to animate 3D models using GSAP in this video, but going into detail on all of these things would make this video too long. So if you want a full crash course on Three.js, just drop a comment and let me know. And before we dive into the main star of this video, which is of course cloning the 3D Apple website with Three.js and GSAP, let me provide a conclusion on this part of the crash course, which is how to use Three.js. There are a couple of ways in which we can use Three.js depending on project requirements and your preferences. You can use Three.js directly in vanilla JavaScript without any additional libraries or frameworks. All you have to do is put a CDN script tag for Three.js. But of course, you can also integrate Three.js with frameworks such as React, Vue, and Angular. Each one of these has its own way of integrating Three.js. We'll use React 3 Fiber, which is a library that allows us to easily integrate Three.js into React applications. And it even makes it possible to create 3D scenes with React components. So, just so you know, you'll learn React 3 Fiber in this video as well. So just to give you an example, in vanilla JavaScript, you would have to first set up the scene by saying scene, camera, and renderer, figure out where you want to render the canvas, and then add a cube to the scene, and maybe even apply an animation. In React 3 Fiber, it's much easier and much more similar to what you're used to. You simply import the canvas and the use frame from React 3 Fiber, and then you import the box or some other element you want to show and call it using hooks and show it with React components. React 3 Fiber acts as a wrapper, which makes it easier to add 3D scenes to our React applications. Enough with theory. Let's dive into action. I prepared a quick workshop for you, and I've linked it for you in the description. Download it, open it within your Visual Studio Code, and then we can install all the necessary dependencies by running npm install. This is going to take just a moment as we don't have too many dependencies. As a matter of fact, we can look into what we do have, and you'll notice that it's basically just React, React DOM, and React Router DOM with some Tailwind CSS. So the entire setup is completely empty. We'll explore everything from scratch. So let's go ahead and run the application by running npm run dev to see what we have on it. And then we can hold the command key and click on this link to open it up. As you can see, I prepared 7 different demos that teach you 7 most important GSAP concepts. So let's dive into the first one by clicking right here, and let's explore GSAP.2. GSAP.2 method is used to animate elements from their current state to a new state. It's similar to GSAP.from, but the difference is that the GSAP2 method animates elements from their current state to a new state, while GSAP.from animates elements from a new state to their current state. And of course, you can read more about it if you head over to the documentation page. Basically, you can see how it works right here. You target a specific element by providing the identifier, and then you specify the properties that you want this element to take after the animation runs. So we are changing the rotation and the X position throughout the duration of 1 second. So now you've seen the demo, right? You could have done on your own without me. But see this box right here. Now we'll animate it together to solidify what we just learned. So going back to the code, we can split our terminal and install a new package by running npm install GSAP as well as add gsap/react, which will allow us to start adding those animations. Once that is done, we can head over to our pages and then GSAP2, as that is the first element we want to animate. In this case, I want you to animate the box that we have right here below. So if you scroll down, you can see a div that has a class name of VW, HW, and then BG Blue 500, which makes that a box. And here we have an ID of blue box. So let me teach you how to animate using GSAP in React. Right below this to do, we can say use GSAP, coming from GSAP React. This is a special hook which looks and behaves a lot like useEffect. Essentially, you define a callback function and then a dependency array on when this has to run. And within it, you can use GSAP to then animate the elements you want. So we do that by saying GSAP, which you have to import from the original GSAP package, .to, and then the first parameter to the .to method is the target you want to animate. In this case, we can target it by ID by saying blue box. Then the second parameter are variables which you want to animate. So you can expand an object, and let's do something like X is 250 pixels. So we animate from x of 0, of course, by default, to x is 250. So now if you go back to your page and reload, you can see how nicely this animates. And just so we can see our animation happening in real time at all times without needing to reload the page, we can add a repeat of -1 as well as a yo-yo property set to true, which will make the animation reverse on every other cycle. So as you can see, now it's going back and forth. Let's pull this to the side so we can continue animating while we're writing the code at the same time. There we go. That's much better. Now, let's also give it a bit of a rotation property of 360. And you can see now it completely rotates. And you can see now it completely rotates. We can also increase the duration to something like 2 seconds. If you do that, it's going to move much slower. And we can also give it a special ease property, which defines how the animation happens. As you can see immediately, you get a lot of different properties you can choose from. For example, bounce in. If you save it, you can see now it kind of bounces in and then stops. You also have bounce out, which is going to make it bounce at the end. There's a lot of these different easing curves that you can decide to use. There's also circle, back, and so much more. In this case, let's use elastic. As you can see, it looks like it's on a spring right now, which you have to pull and then move back and forth, which gives it a very interesting effect. But with this in mind, you just learned how to use one of the fundamental methods in GSAP, which is GSAP.toProperty, which accepts an ID, which is an identifier, and then properties you want to apply to the element you're targeting. You also learned how to apply animations using the use GSAP hook and GSAP within React. So with that in mind, let's go back to the homepage and navigate to the second method of the day, GSAP from. As the name suggests, GSAP from is used to animate elements from a new state to their current state, similar to GSAP 2, but the difference is that the from animates from the new to the current, while GSAP 2 animates from their current to a new state. Of course, you can find more information within the docs. But for now, let's implement it in action. I'm going to go back to GSAP.to and copy this entire part. Then I'm going to navigate to GSAP from and simply paste it right here below. Of course, not forgetting to import the use GSAP as well as GSAP. Now, if we modify the method from to from and modify the ID from blue to green and save, you can see that it started moving from the back and then going to the front. In this case, let's explore a bit of a different ease, one I like to use often, which is power1.in.out. This one starts with a lot of power and then slows down, as you can see it right here. But the most important thing is that now it starts from the position 250 pixels in. If I reload, see how it started from the right side, moving to the left. That is the only difference between from and to. The next method of the day is GSAP from to, which, as the name suggests, is used to animate elements from a new state to a new state, similar to from and to methods, but the difference is that here you can define both states. So if we scroll down, we can copy the entire thing we have here and navigate to from to. So let's paste what we copied, import the hook as well as GSAP. We can modify the method from to, and you still pass a specific identifier, but this time you have two different objects you can modify. We have the first object, which is the from object, and then we have the to object, which accounts for the two properties we want to implement. So let's try to animate it from an x of 0 and a rotation of 0 with something like a border radius of 0% as well. And we're going to animate it to 250, repeat -1, and let's also add a border radius of 100%. And we can also modify the ease to something like bounce out to explore another one. Now, if we modify the identifier from green box to red box and save it, now you can see how it turns from a square into a circle and then comes back. So we're modifying the rotation and the x and the border radius to 0 at the start, and then at the end, we set it to 100, which essentially makes it a circle. This is pretty useful when you want to modify both the start and the end of an animation. With that in mind, those have been the 3 base GSAP methods. But let's explore what else we have in store. Next one on the list is the GSAP timeline. And the GSAP timeline is used to create a timeline instance that can be used to manage multiple animations. Again, it's similar to to, from, and from to, but it is used to manage multiple animations, while all of these manage just one element from their current state to a new state. Of course, we can open up the docs to learn a bit more about it. And in this case, you can see that they consider it a sequencing tool that acts as a container for the other animations we have explored. It allows you to have complete control and manage the timing of an animation. So instead of doing something like this, first do X100, then do Y50, and then change the opacity to 0, you can create a timeline, and then you can modify the elements to move on that timeline. You can also control the whole thing easily by pausing it, resuming it, reversing it, and so much more. So with that said, let's animate this yellow box and also include the play and pause button. So we can navigate over to GSAP timeline. And you can see at the bottom, as we always do, there is a div that has an ID of yellow box. So first things first, when creating a timeline, we have to define it by saying const timeline is equal to GSAP, which you have to import from GSAP, dot timeline. And then you call it like this. Next, you can also pass the options object to give it some properties, like repeat -1, repeat delay of something like 1 second, and yo-yo to true. We already learned what this does. It simply makes the box move left and right. It simply makes the animation repeat, so we don't have to reload the page to check out the animation. Now that we have the timeline defined, we can use the same use GSAP hook we have used not that long ago, define the callback function, as well as the dependency array. Now within it, we can use the timeline.to property instead of using the GSAP.to property. And it works in the same way you have seen it before. It's just timeline.to, you then define the identifier, which in this case is the yellow box, and the second parameter are the variables you pass to it, such as the X is 250, rotation is 360, border radius is 100%, duration is 2, and then ease is back, dot, and out. Again, this doesn't matter too much right now, but we're just playing with the way that the animation actually executes. So if we save it now, you can see how it goes from one end to another and comes back. Now, what we can do is we can also say timeline dot to, again, target the same yellow box, and then provide another set of variables we want to apply to this animation, such as x500, scale of 1, rotation of 360, border radius of something like 8 pixels, duration of 2, and ease of back, dot, and out. Now, if I save this, you can notice that it's yellow and then it goes further out of the screen. I'm going to zoom this out a bit so you can see the full animation. First, it goes to 250, waits a bit and moves to the end, and then it returns. Now, this is a bit similar to using the from and to, or the from to, but what this allows us to do is to add additional animations in the middle. So we can say timeline.to, once again, where we target the yellow box. And this time, we can, for example, do the Y of 250, scale of 2, rotation of 360, border radius of about 100%, and duration of 2, as well as the ease, back, dot, and out. Now, if we save this, we have added a third animation to the mix, where now it will actually go down out of the screen, move back, and then it's gonna come back again. So these animations are happening in a row, one after another, which gives you a lot of possibilities to control the entire timeline. Now, another thing you can do here is, of course, play and pause it, because you have complete control over the timeline. So let's head over to our play and pause button, which is right here, and let's expand this on-click functionality. we can define an if statement and say if timeline.paused is true, then we want to trigger the timeline.play, and also else vice versa. Then we want to run the timeline.pause. So if we do this and save, now you can click play pause and completely pause the execution of the animation. Then you can trigger it again and it works. So I think you can see the benefits of running animations within a timeline. You have more control. Now let's move over to the fifth method in the GSAP repertoire, stagger. GSAP stagger is a feature that allows you to apply animations with a staggered delay to a group of elements. By using the stagger feature, you can specify the amount of time to stagger the animations between each element, as well as customizing the easing and the duration of each individual animation. This enables you to create dynamic and visually appealing effects such as staggered fades, rotations, movements, and more. And of course, you can find more within GSAP stagger documentation. They even prepared a little video. But in essence, it is as easy as using the stagger property. So let's explore it in action by navigating over to the stagger file. In this case, if you scroll down, you'll notice that we don't have a single box with an ID of box. Rather, we have multiple divs that all have the same class name, stagger box. So instead of simply using an ID, we'll use the class name as an identifier. So same thing goes, we can use the use GSAP hook, create a callback function, and then we can use the GSAP.to method. And in this case, we can import GSAP from GSAP. Now, you might say, hey, we already learned to, but we haven't used stagger. Well, stagger is just a property you can apply to any animation. So we'll use to show this out, to explain the stagger by targeting the .stagger-box, and then we can provide the options. In this case, we can do the same thing we've done before, such as Y of 250, rotation of 360, border radius of 100% to turn it into a circle. We can add a repeat of -1, as well as a yo-yo of true. Now, if we save this, you can see they all follow the same animation as we're targeting all of the elements simultaneously. But what if we want them to animate one by one? Well, in that case, we can provide a stagger property of 0.5, let's say. So now we can save it, and you can see that now, after half a second, each one of this animates, one after another. But it doesn't end there. We can also apply more complex stagger properties by defining stagger as an object. Here, you can provide the amount, which is the amount of time to stagger the animations between each element, and we can say something like 1.5. Then you also have access to something known as a grid. Grid selects the number of columns and rows in a grid, so you can say something like 2, 1. Then there's also the axis, and you can choose the axis along which to stagger the animations. In this case, we can say Y, but you could also say X, in which case they all happen at the same time. Next, you can also apply the ease, which in this case, we can do something interesting like circ, dot, in, out, and now kind of they happen in a circle. And finally, this is the most interesting one, you can define the from, which is the starting position of the staggered animation. So instead of starting from the start or the end, we can say center. So this will make it start from the central staggered box. As you can see, now it happens from the start and moves until the end. And you can also see how they're doing 2 and then 1 and so much more. So you have complete control over how you want to stagger your elements. This is great. So now you know how stagger works and how you can use it when you have multiple elements which you want to animate, and let's call it a dance of sorts. The next feature on our list is the scroll trigger, which is used to trigger animations based on the scroll position. So as you scroll, you can animate specific things once you reach a specific point in time. So for example, scroll down to see the animation, and then only after you reach a specific point, we want the animation to start. So let's first open up the documentation page, and I always advise you to read the docs for anything you're doing. There's also a quick video right here. And the simplest way is to attach a specific target, which when it enters the viewport or the screen, then the animation happens. or you of course have much more control over when the animation triggers. In this case, we can go back and go to GSAP scroll trigger, and let me show you how to implement it. First of all, it's very important to note that GSAP scroll trigger is a plugin, which means that we have to initiate it at the top by saying import scroll trigger from GSAP all, and then you can do GSAP, which we have to import from GSAP, dot register plugin, and then you pass that scroll trigger. This will make it work. Next, with triggers, you also have to define a reference. So we can say scroll ref is equal to use ref coming from React. This is not GSAP related, this is just React. Then we can use the same old use GSAP hook coming from GSAP React, which we can define like we have done so far. Now, in this case, if you scroll down, you'll be able to see that we have some boxes right here. Now, if you scroll down, let's attach that ref to our boxes. So if we scroll here, you can see that we have two boxes, the scroll pink and scroll orange, and we can attach a ref to this div wrapping both of them by saying ref is equal to scroll ref, like this. Now we can scroll to the top and we can start animating. So first, let's get access to those boxes by saying const boxes is equal to gsap.utils.toArray, and to it we pass the scroll ref .current.children. So this is how you can get the children using a React ref. Next, we can also run the boxes for each. So for each box, we want to do something, and that something will be a simple GSAP.to animation where we target each individual box, and for each one, we apply some specific properties. In this case, we can say X is something like 150, rotation is 360, border radius is something like 100%, scale is 1.5. We have learned that already, right? So now if we scroll down, you can see that they basically already turned into circles, even though we didn't see it at all because we were at the top when the animation was happening. Not too useful, right? Typically, you want to have some animations when you scroll up to a specific point. Like if we're here, we can see it, sure, but the user will come from top and then we'll start viewing this at the bottom. So this is where scroll trigger animations come in. To this GSAP2 property, we can apply a scroll trigger, which is an object to which you can pass a trigger, and then this one will be a box. So once specific box comes into view, we want to start the animation. Let's see that once again. If I start scrolling down, already it's a circle, but that's because we're missing something important. We're missing the start of the animation, which we can define as bottom. So when the bottom of the box hit the bottom of the viewport, then it will animate. And we can also define when it will end. And it will end when the top of the box hits 20% of the viewport. We also have something called scrub, which we can set to true, which makes the animation smooth. And below the scroll trigger, we can also define the ease of power1.in/out. And the reason why the scroll trigger animations are not working is because I misspelled it as scroll instead of scroll with a double L. So if we fix this, now check this out. I'm gonna scroll to the top, reload the page, and start scrolling down. So now, as we enter the viewport slowly, you'll see how this starts as a box because that's what it styles, say by default, and then slowly it starts moving to the right and it starts applying the rotation, border radius, and scale as we scroll. Check this out. Interesting, right? And also, it goes back immediately. Now, another thing is that since we're mapping over those boxes, we can apply a bit of math to each one. So instead of just moving it x 150 for each one, we can multiply that by boxes dot index of a specific box. So this will already apply it a bit differently because the second one has an index of 1. And we can also give it some default value like +5. So now if we start scrolling down, You can see how nicely they animate and exit out of the screen. We come back, they are back. And of course, you can keep playing with these value like top 30%, which will make them go away much sooner, or like something like top 10%, which will make them in the screen for a longer period of time. It's up to you to start playing with this. And I just noticed we don't need a comma right here. It's just bottom. So like this, yeah, that's great. Another thing you can add when you're animating using the scroll trigger is if you go all the way to where you end the use GSAP function, which is here, you can also provide a second parameter of scope is scroll ref, like this. That way it will know exactly when the animation has to happen. So now I'm sure you have already noticed how useful GSAP is, specifically simple properties like GSAP2, staggering, and so on, but only when you pair it with scroll triggers, which we'll do a lot within this video, and it's also covered in a lot of depth within our ultimate guide, which you can find in the description down below, completely for free. You notice how it all starts coming together when you combine all of these properties. And finally, we have GSAP text, where I'm going to teach you how to animate text elements with GSAP. So to animate text, you can use all the methods we have explored so far. The only thing you have to do is integrate the text plugin. You can see it in the docs. Basically, you can add the GSAP2 and then add the text you want to animate. You also have some special properties for animating text elements. So let's head over to text. And you can see an H1 here that says GSAP text, but it's nowhere to be found on the screen. It's kind of like it's being hidden, right? And that's because it is. At the start, the opacity is 0. So let's go ahead and animate it in. We're going to use the same old tips and tricks like use GSAP coming from GSAP React, where we have our callback function. Then we will define GSAP.to, which we have to import from GSAP. We target the text element by ID of text, and then we provide some properties like ease, which will be power1.inout. Once again, you can go without this, or you can find the ones that you like and then add different eases. And then I'm going to add opacity of 1 as well as y of 0. So this is nothing new, right? We're just changing some properties using GSAP2, and you can see how nicely it slides in. Great. Now, let me also teach you how to animate the paragraph. You can see this para class name right here. It combines all of these properties that you can see. So let's add a GSAP.from2 in this case, and we can target the .para, which is the paragraph. And then, as you know, with from2, you have to define 2 different objects. And at the start, this text is visible. We didn't apply an opacity 0 like we did here. So you can apply it here in from. Opacity 0, y of 20. And then, of course, it's going to break until you provide a second object where you can reset the opacity to 1 and y to 0. So now you can see how nicely it fades in. We can also apply other things we learned, such as the delay between the elements, as well as the stagger of 0.1. So now different paragraph elements are going to animate one after another. And with that, we came to the end of this little GSAP workshop. As I said, we go into more detail on all of these and many other more advanced GSAP properties within the ultimate GSAP and Three.js guide, which you can find below. So check it out and get warmed up for the main star of the show, which is diving a bit into Three.js and then combining the Three.js knowledge with your GSAP knowledge and building something on your own. It's one thing to watch me do things and then enter a couple of methods, and it's a completely different thing to build something truly useful and replicate what some of the best companies in the world do. So, how do you feel about these GSAP features? We'll explore everything in more detail later in the video. GSAP also offers plugins for physics and motion that allow you to create animations with realistic physics-based motion such as bouncing, elasticity, and acceleration. And yes, I know we covered a lot of ground regarding GSAP in a short amount of time, which is exactly why I prepared a complete GSAP guide and cheat sheet down below. So download it and save it somewhere for reference. It's completely free. Also, leave a comment down below if you're interested in a more detailed and more advanced GSAP crash course. But with that said, that's enough theory. So let's get started. The first step in building our app is setting up our hosting. I want to teach you how to deploy this incredible app to the internet so everyone can see what you've built. See, the app you'll build today isn't just a project, it's a career asset. It's designed to showcase everything you're capable of, making you an attractive candidate for any job. I highly recommend Hostinger for this app. They're offering an amazing deal right now. I'll go for the business plan. Here's why it's perfect for this project. You get up to 5 times increased performance, free SSL for HTTPS security, which builds trust with anyone visiting your website. You also get a free domain name, giving your website that professional touch, and a free CDN to speed up your site. It ensures that your website loads quickly, improving the user experience. And because we've partnered with Hostinger, you get an even bigger discount. So click the special link in the description, click Claim Deal, and Add to Cart. Here, we have to choose the period of our hosting, and I'll choose 48 months to save the most. Down below, you can choose your payment method and enter your JavaScript Mastery coupon code, which gives you the biggest available discount on your hosting package. And once you purchase, we are ready to set everything up. Right within Hostinger's guided setup, it's asking us what tool we want to use, WordPress with AI or the Hostinger website builder. In this case, we are real developers, so we're going to click skip as we want to develop our own website. And I love this UI. As you can see, I'm using Hostinger to host our official jsmastery.pro website. There, you can check out our ultimate Next.js course, or if you're a bit more advanced, the JSM Masterclass. Let's try something like jsmphone.com, and it is available. So I'm going to click right here, and of course, you can choose your own preferred domain name. Click Next, and once your domain registers, you'll also be able to choose where your website target audience is, so that way it loads fastest for them. I'm going to leave it as the default and click Next. While our hosting is getting set up, I just want to let you know that there's a complete GitHub repository for this project. So if you ever get stuck, or if at any point something is not working for you as it is for me within the video, come here, refer to the code base, and fix it. Also, don't forget to give it a star. Our hosting has been set up. At the end of the video, we'll deploy it using the file manager. With that said, let's dive right into the code. To get started with building our amazing 3D Apple website, we'll begin from bare beginnings by creating a new empty folder on our desktop. I'm gonna rename it and call it Apple_website, and then drag and drop it into an empty Visual Studio Code window. Once you do that, we are ready to set our project up. To quickly get ready with our development environment, we'll use Vite. It will allow us to quickly spin up a React application with a lot of interesting things provided out of the box, like the instant server start, optimized build, hot module replacement, and more. But of course, if you want to build this project out with another technology like Vue, Angular, or even better, Next.js, I would be more than happy for you to do that. You're going to learn even more by building it in your technology of choice. So with that in mind, we'll use Vite. And with Vite, we'll also use Tailwind CSS, which is a utility-first CSS framework packed with utility classes for easier styling. So with that in mind, let's go to Quick Search and let's search for Vite or your own preferred framework. Once you're there, we can copy the command and quickly get started with our application. Back in our editor, I'm gonna press Ctrl Backtick, which is a shorthand for quickly opening up the terminal, or you can go to View and then Terminal. Once you're there, you can paste the first command that we copied, but I'm going to change my project with /, which will ensure to create all of the necessary files and folders right within the new Apple website folder we created. So press Enter. It's going to ask us whether we want to install the create Vite CLI, to which we can say Y, yes, and then run npm install to install all the necessary dependencies. And once that is done, let's follow the next steps right here. You want to install all of the necessary Tailwind config, so let's copy this npm install Tailwind CSS, post CSS, and auto prefixer, paste it here and press Enter. Let's also initialize a Tailwind project. Next, we need to update our template paths by copying this content, navigating over to tailwind.config.js. And by the way, pro tip, the way I just navigated is by using Command or Control and then P. You can start typing and you can immediately press Enter to navigate in another file, or of course, you can use your mouse and go right here. With that in mind, I'm gonna update our content, and then we can follow the next step, which is to add Tailwind CSS directives to our CSS by copying it, going to our index.css, removing everything, and pasting just these 3 Tailwind directives. Once we have that, we can add a simple h1 to our app. So let's navigate to our app.jsx, remove everything from the return statement like this, and simply return a simple h1. While we're here, let's also remove all of the other things that we don't need. And we can also remove the app CSS, as well as removing that file as it's creating clutter. There we go. We can also rename this to an ES6 plus arrow function. There we go. So now that we have this, let's reopen up the terminal and run npm run dev. Then you can hold Command or Control and then click right here to open it up on localhost 5173. And we are in. We can see that the text is enlarged, underscored, and bolded, which means that Tailwind CSS classes are getting applied properly. Now, let's turn this empty canvas into this, a modern 3D Apple website with GSAP Animations and 3D models. And before we begin, another pro tip for new developers out there, you might notice that my browser is looking a bit weird. This is not your typical Safari or Chrome bookmark bar. I'm using a new browser called Arc, which is very convenient and allows you to focus on what matters. It is of course built on top of Chromium, so you always have all of the typical Chrome features you're used to. And they're available for macOS and as of recently for Windows too. And no, this is not a promotion. I just wanted to share it with you in case you're interested. And before we begin setting up our file and folder structure, we have to set up our linting. That will include ESLint and Prettier. So in the description down below, I created a special guide containing the configuration that I personally use on all of my projects. And the guide will look something like this. It is a 22-page PDF that covers ESLint Prettier in Visual Studio Code for both React and Next.js. Starting from the introduction on what ESLint even is and why do we need it, and then moving on to a complete setup using Next.js. But what you're more interested in for this video is the setup for React. All of that is included in this simple PDF. And once you get it, you'll also be added to JSM Weekly, which is our official newsletter, where every single week we share some news from the web development world. There is no ads, just fresh information on React, Next.js, and web development in general. So download the guide, implement the linting, and we can continue. Now let's set up the base file and folder structure and the styling for our project. First things first, we want to navigate over to the tailwind.config.js. And here we want to set up some basic colors. So we can go under theme and under extend, then extend the colors. That's going to be an object where we can add a color blue, which is going to be #2997FF. Now, every time you want to add a specific color, you just say blue. You don't mention these 6 random characters. And alongside adding the blue, we also want to add a couple more colors. And to quickly add them, just click the README link in the description, navigate over to snippets, and then here you can find all of the snippets for this video. As you can see, there aren't many. The first one is the Tailwind config.js. Alongside adding the blue, we're also adding a couple of variants of gray for our different text elements and a zinc color. So let's copy this entire snippet and let's simply override what we have here. The second thing we want to add when it comes to styling is the index.css. So expand it, copy it, and then back within our code, navigate to index.css and override everything we have here. You'll notice we have about 120 lines. But all of these lines are helper classes, providing some text colors, text variants, and more. So if we scroll all the way up, you can see we're targeting the body by making some default modifications, and then adding some utility classes like nav height, btn, color container, and more. We'll refer to these throughout the build of this video. But these are in no way all the styles we'll be using in this video. You will write all of the styles yourself These are just some helper classes to get us going. Next, in our file tree, we also have the assets folder, which for now simply contains the react.svg icon. We want to remove that assets folder, go back to the README within links, and then download our own assets containing all of the assets for the build of this phenomenal Apple website, including the 3D model we'll be using. So click the link here and simply download it from our Google Drive. It's gonna say we cannot scan it for viruses, but I think you can trust me on this. Once you download it, simply delete this public folder right here, and then drag and drop the new one into the root of our directory. Click Copy Folder. And here you'll notice that we have our 3D models as well as the assets. Now, to quickly use these assets within our code, we're gonna create a new folder called utils. And within the utils folder, we'll create a new file called index.js. Back in our README, you can expand this index.js, copy it, and paste it right here. You can notice that here, we're basically importing all of the images and then exporting them so that we can quickly use them within our project. And the last thing we need are the constants. These are some predefined arrays of information, like content or text that we'll use within this project. For example, see this Enter A17 Pro game-changing chip. Back in our app, you can see where this text goes. So what we're doing here, we're preparing the content for the entire application. Everything from nav items to footer items and more. So let's simply copy it. And within the source folder, create a new folder called constants, and create a new index.js file, and paste everything we copied. And as you can see, there's zero logic happening here, just content which we can consume when we actually develop our website. So with that in mind, let's prepare for the development by going into our index.html, and let's modify our icon. We can go from Vite SVG to a new icon coming from our assets. That's going to be public, assets, images, apple.svg. So /public, /assets, /images, /apple.svg. And we can also change the title of our application to Apple iPhone. And save it. Now, if we go back to the browser, you can see that now we have this great looking Apple icon as well as the title, and we're ready to turn this into this. So let's dive right into the development. I'll start by diving right into our app.jsx. We want to remove this h1 and instead turn it into a main section and give it a class name equal to bg-black. Then within here, we want to have a couple of components, such as the navbar, the hero section, and the highlights. I think that's enough to get us going. So let's create these three as components by creating a new components folder, and within there, creating a new file called navbar.jsx, inside of where we can run rafce and press enter. This will quickly spin up a new React arrow function component called navbar. And if this didn't work for you, you need an extension called ES7 Plus, Redux React Native Snippets. So simply install it and it should work. Alongside the navbar, we're gonna also get our hero section by saying hero.jsx with rafce, and we'll also get our highlights component where we can run rafce. Now we have three most important components. Well, maybe second most important, as our 3D model is the star of the show. So now let's go back into the app. Let's turn these three into a self-closing and self-calling components, and let's import them at the top by saying import navbar coming from /components/navbar. And we can duplicate this 3 times and rename the second one to hero and the third one to highlights. Finally, let's see if we can see anything in our browser. I'm going to pull our browser to the side and my code editor to the left. Now, if I zoom this in a bit, you can see that we have our navbar, hero, and highlights, which gives us a lot of room to start working on stuff. So let's get started from top to bottom with the first component of the day, the navbar. To start developing it, we can transform this div into an HTML5 semantic header tag, and within it, we can render a new nav tag. This nav will render an image, and that image will have a source equal to Apple IMG, like this. We can import that Apple IMG at the top by saying import Apple IMG coming from /utils. If we save it, you can see the Apple logo appear instead of the text that says navbar. Let's give it an alt tag of Apple, a width of about 14, and a height of about 18. Within this image, we're going to have a div. Within this div, we want to render all of our nav items, and that's going to be dynamic. So we're going to have an array of something like, let's say, I don't know, phones. We can also have MacBooks, and we can have something like tablets. And we're going to map over this array by saying .map, where we get each individual nav item and its index. And for each one, we want to immediately return a div that will render that specific nav item. This was supposed to be a comma. There we go. So now we can see phones, MacBooks, and tablets. We can also give this div a key equal to the index that we're mapping over. Or in this case, we could also just make that the nav text itself, because we know that it will always be unique. Finally, going below this div, we want to create another div, which will contain an image. This image will be the search image. So we can say source is equal to search image coming from utils. I just automatically imported it by pressing the enter key, so you can see it got it from here. And we can also give it an alt tag of search, as well as a width of 18 and a height of 18 as well. We can duplicate that below, and we can also get the bag image from utils in case we want to buy something. Of course, I'm going to change the alt to bag. If we save this, you can also see the search and the bag, all very minimalistic, as Apple always is. So now that we have the layout of our navigation bar, let's start adding the styles. I'm going to give our header a class name equal to w-full, so it takes the full width of the screen. Padding Y of 5 to give it a bit of a padding top. On small devices, padding X of 10 to divide it a bit from the sides. Usually, padding X of 5. We're going to give it a flex container like this, where we want to justify the items between and items-center to vertically align them in the center of the screen. More importantly, we want to make our inner nav a class name of flex, which will immediately make all of the items go one next to another. We also want to give it a W of full, so they span across the entire screen. And we also want to give it a screen max width. So this will ensure that it takes the full width of the screen. Now, if we go into our index.css and at the top search for this screen max width, you can see that I misspelled it as scrim. So let me just say screen max width. And that way this will be applied and it will give it a max width of about 1120 pixels. Now let's style our class items by giving them a class name of flex. That's going to make them go one next to another. Flex of 1, justify -center, and on max-small devices, so devices with a width of 600 and less, we want to make it hidden because they don't all fit, right? So we can eventually expand it, but for now, we cannot fit them all. Also, it's not good to have this content right here and mess the content with the actual JSX, which we're presenting. So with that in mind, we can import this content from the constants by saying import nav lists from /constants. That way, instead of rendering this entire array here, we can simply say nav lists.map. And this nav lists contains store, Mac, iPhone, and support. We cannot see it now because we have hidden it on small devices. But of course, if we expand it, you'll be able to see that it's there. Of course, I need to zoom out quite a lot. There we go, and go back. Great. Now, let's style each one of our list items by giving it a class name equal to padding x of 5. And it might be good to come back to larger devices so we can properly see it. There we go. That's more Apple-like. Let's also give it a text-sm, so a bit smaller. Cursor-pointer, so we know they're clickable. Text-gray. There we go. Because we don't want it to take away from what's in the middle of the screen. We want them to buy the items. On hover, we're going to make it a text of white. And we're going to give a small transition -all so that it nicely animates as you hover over it. There we go. That is looking great. Now we can go back to a smaller screen and we can style the icons to the right side by styling this div and giving it a class name equal to flex, items-baseline gap of 7 in between the elements. On Mac's small devices, justify end, and on Mac's SM devices again, flex of 1. So this is going to make the items nicely appear on the right side. Of course, if you want to, you can also add a hamburger menu, but for now, this is looking good to me. And of course, it looks great on desktop devices as well. This was just a super quick navbar, which means that we're now ready to start focusing on the hero section. So let's hold our command or control and then click into the hero section to start developing it. Our hero section will be just that, a section. So we can write section, and then we can also give it a class name of w-full for full width, nav height, which will make it come below the navbar, bg of black, and position of relative. Now within this section, we're going to display a div with a class name equal to h-5/6. So this is a height of about 83%, as you can see right here. I can see it because I have a Tailwind CSS IntelliSense extension installed. If you don't see this, you might want to install it. But now, what does this mean? You can see that now it pushes the highlights below, which means that the section is taking the full height of the screen. Let's also give it a w-full, a flex-center, and a flex-call, so the elements appear one on top of another. Within it, let's render a p tag, and let's make it say iPhone 15 Pro. There we go, in the middle, minimalistic as Apple does it, and let's give it a class name equal to hero-title. Now, as you can see, this hero title got completely hidden away as soon as we added this class name. Why is that? Well, if you're wondering what are the styles applied when we give a specific Tailwind class, you can always copy the name of that class and then head over right here, paste it, and find it within the index.css. And here you can see that we are applying some things like text center, font semi-bold, text 3XL to make it bigger, text gray 100. But hey, what is this? Why are we applying an opacity of 0? Why are we hiding it? Well, looking at the deployed site might give you a hint. Let me reload so you can see it. At the start, the text wasn't there, but then it popped up. That means that initially we want to hide this piece of text, but then we want to animate it in. So let me teach you how to do that using GSAP. GSAP is probably the best and a widely robust JavaScript animation library built for professionals. Let's scroll down a bit to see what they're about. They are going to allow you specifically, yes you, because you're watching this video, to effortlessly animate anything JS can touch. Smooth performance, and you can focus on the fun stuff, animate literally anything. It looks great. It feels great. I think I'm sold, right? Let's see how we can use it. Back in our code, we can open up our terminal, split it to get a new one, and run npm install GSAP, as well as add GSAP /React, and press enter. This just installed all the necessary libraries, and it allowed us to import two things. Import GSAP from GSAP, and import use GSAP coming from GSAP /React. Now, right at the top, we can call this use GSAP hook like this, just as you would call any hook. And to it, you provide, first of all, the function containing your animations, and then dependencies when it is running. So here, we're going to have a callback function, and then as the second parameter, we'll have an empty dependency array. Within here, we can then use the base GSAP to animate something. Specifically, we're going to say GSAP.to. So we want to animate two specific values. We know what the default values are, right? The text, or rather the lack of text right here, as the opacity is 0. So given that we know that fact, we can now target this element by a class or an ID, and then give it a new value that it will animate to. So in this case, I'm going to give this p tag an ID equal to hero, but you might as well target it by a class name if it's unique. Then say hash hero, as it's an ID, and then here provide an object of the properties you want to give it once it animates. So that's going to be, in our case, opacity of 1. Now, if I save this, you can see how it nicely animated. It was very quick though, but you can also play with the delay or the duration. In this case, let me set the delay to something like 1.5 seconds. So if I do this, you will notice that once you reload, there's nothing for 1.5 seconds, and then it animates in. And with that, my friend, you have just implemented your first GSAP animation. Pretty simple, right? Trust me, we're gonna get into much more complicated GSAP animations, but be happy that you've done your first one for now. Now, the second thing is to get this video playing right here. And yes, it's a video, although you would never assume so. So going below our p tag, we can render a div, and that div will render a class name equal to, on medium devices, width of 10/12, which is about 83%, and usually width of 9/12, which is about 75%. Within there, we can render an HTML video tag like this, and we can give it a source. This source is a self-closing tag that will have an src property of video src, like this, which we can import at the top by saying import hero video from /utils, as well as small hero video. Why small? Well, that's because we'll have two versions of the video depending if we're on desktop device or tablet, or if we're on the phone. So let me show that to you in action. We can reload this screen, and you can see that here, it's very small and narrow, perfectly fits on your phone. But if I go to a desktop device and reload, you can see that here we have a horizontal iPhone turning around. How cool is that? Exactly like on the Apple website. So to achieve that, we first have to figure out the width of the screen. And for that, we can use a use state hook, and we can call it video src. So video src and set video src. Exactly what we have here under the source. Then here, we want to figure out what is the inner width of our window. And we can do that by saying window.inner width. And if it's lower than 760 pixels, then we make the video source state equal to small hero video, else we make it just a typical hero video. And of course, we have to import use state from React. Now, if we go back to our current application and reload, you can see that something happens in the middle, but not too much happening yet. So let's also give it a type equal to video / MP4. And in the video tag, let's give it auto play, muted as we don't want any sound, plays in line will be set to true, and we want to give it a key to this video, which will be equal to video src. If I save it, you can see the video started playing, and it doesn't even look like a video. We can also give it a class name equal to pointer-events-none, so nobody can click it or mess with it. So now if I save it, looks great. But if I expand my screen, oh, that's not good, right? So let's make it dynamically modify the video depending on the width of the screen. We can do that by saying const handle video source set like this. And this will be a function that's simply going to look into the inner width of the window by saying if window.inner width is lower than 760 pixels, then we want to set the video source to small hero video, and else we want to set the video source to be the big hero video or just hero video. And now we can connect that to our use effect. So let's create a new use effect hook like this with an empty dependency array, and don't forget to import it at the top. Then we can say window.addEventListener, and we're listening for a resize of the screen. And whenever we resize, we want to call the handle video set source. And in React, it's very important to clean up your event listeners as well, which you can do by returning a function inside of which you can run window.remove event listener resize, and that's going to be the handle video source set like this. So this way, you can notice that on big screen, we're playing this wonderful looking horizontal iPhone, and on smaller screens, we're playing this great looking smaller screen iPhone. How cool is that? So now we can collapse these functions, and we can scroll down to start adding our call to action button to actually purchase this gorgeous iPhone. So let's head below the video and below two more divs, and let's create a new div which will have an ID equal to CTA, as in call to action, and it will have a class name equal to flex-call, so the elements appear in a column, items-center to center them on the screen, opacity of 0, and translate-y-20. I think you already know why I added the opacity 0, right? We're gonna animate it. And I also added the translate for the same reason. This is simply going to translate it by 80 pixels to the bottom on the y-axis. So later on, we'll be able to animate it so that it flies up the screen. So within this div, we can create an anchor tag that will have an href of hash highlights. It's going to lead us to the highlight section. And we can give it a class name equal to btn. Here, we can simply say buy. Now, of course, we cannot see it yet. And below this one, we'll also add a p tag that will say from $199 per month or $999 if you're purchasing right away. We can give this p tag a class name equal to font-normal and text-xl to make it a bit bigger. But now I have a small task for you. Figure out how to animate this div, including the anchor tag and the p tag. Hint, it's going to be happening within our use GSAP hook. So pause this video and give it a try. What we can do here is once again call the gsap.to function and then target the hash CTA ID, and we want to animate to the opacity of 1, and we want to also push it a bit up by giving it a y-axis of -50, which will push it up. And we can also give it a delay so that it happens hand in hand with the animation of our H1. So we can say 1.5 seconds. Now you can see how both the iPhone 15 and the buy button and the text animate in at the same time with the video. So let's reload and see it all in action. The video shows up, and then iPhone reveals itself, and then we have the pieces to buy the text. But hey, we don't want to buy it before we can actually see the iPhone, right? So let's bump up the delay to about 2 seconds. Save, reload. The video shows up, the iPhone comes up, and then at the same time, the buy button and the iPhone text shows up. How cool is that? I'm very excited. Let's also check this out on the entire screen by reloading, checking it out, and there we go. The text is here as well. Who would have said? We have already developed the animated hero section of the Apple iPhone website. But of course, don't go just yet, as we have many more interesting things coming up, such as this cool section where you can actually move through different sections playing different videos, and it all feels like it's a part of the website. You can also go down and then see the entire 3D model, and you can move it around. Also, you can change the colors, and you can get to a bigger screen version as well. How cool is that? So with that in mind, let's focus on developing the second section of the day, which is this animated highlights section. I'm gonna bring my browser once again to the side, close the hero and the index, and navigate into our highlights section. To get started with our highlights section, we can turn it into a section and give it an ID of highlights so that we can then scroll through it from our homepage. That way, if we click buy, later on we'll be able to see the highlights section. Now, let's also give a class name to this section of W-screen, which will give it a full width. Let's give it an overflow of hidden, so we don't see any scroll bars. H-full for full height. Common-padding for paddings. And BG-zinc for this nice looking background color. It's very similar to this full black, but just a bit different. Let's create another div right within this section with a class name equal to screen max width, and within it, let's create another div that will contain our H1. So here we can create an H1 with an ID of title, so we can soon enough animate it. Let's give it a class name equal to section-heading, and let's say get the highlights. Of course, if you buy the iPhone, you get the highlights. So we cannot see it right here, as right now, if we check the section heading in the class names, you'll notice that we apply the opacity 0 and translate Y20, so it's actually hidden. So to get it showing, you know what we need to do. We can use the use GSAP hook like this from React, call it, provide a callback function, and an empty array. Then we can say gsap.to, where we animate a title, and we animate it to the opacity of 1 and a y of 0 to reset its position. And of course, we can import GSAP from GSAP. Now, if we save this, you can see how it not only shows up, but it also comes from the bottom to the top. Great. Now we can style this div within which we have this H1 by giving it a class name of MB of 12 for margin bottom. We can also give it a W-full, items-end, and justify-between. This way we'll have the highlights on the left and something else on the right, especially on bigger devices. What I'm referring to are these two little pieces of text on the final website, which is this watch the film as well as watch the event links. So let's add those by creating a new div directly below the H1. That div will have a class name equal to flex, flex-wrap, items-end, and a gap of 5. Directly within it, we can render a p tag, and this p tag will say watch the film, and then we can give this p tag a class name of link, and right below the text, still within the p tag, we want to render an image. This image will have a source equal to watch img coming from utils with an alt tag of watch and a class name equal to margin left of 2. Now, if I save this and go back to our current version of the application, we cannot yet see it as we're not really animating it in. So what we can do is also run the GSAP.to. This time we're going to go for the .link class name, and we're going to animate it to opacity of 1, y of 0, and save. Once we do that, you can see watch the film here. Now, directly below, we're going to duplicate it and create another link that's going to say watch the event. And here we can say write img coming from utils, and this will be right. Now, it looks like it comes below the highlights, but we want it to appear on the right side. So what we can do here, looking at this div, it looks like the items end and justify between properties haven't been implemented because it doesn't have the flex display. So we can say on medium devices and larger, we can give it a flex display. And this will make the links appear on the right side. But now pay close attention. You can see that they all appear at the same time. Whereas on the finished side, you can see how they slowly animate in one after another. So to achieve that look and that animation, we can give it, first of all, a duration of 1 to increase it a bit, and then a stagger of 0.25. Stagger will ensure that they only stagger one after another, all of which have the same class name or the same selector, in this case, .link. We have a link here, and we have a link here. So now if we go back, you can see highlights first, then the film, then the event. Great. So with that in mind, the top of the highlight section is done, but of course now the fun part begins. We can focus on the video carousel component, something that you don't really see often. So to create it, let's go below the speed tag and below two more divs and create our own custom video carousel component by going to components, saying video carousel, .jsx, run rafce, and then go back and render it right here. Video carousel, and self-close it. Of course, we have to import it at the top by saying import video carousel from /video carousel. Now you can see it right here. I'm going to collapse it as we'll be doing it for mobile devices as well, which means that we can now dive into the video carousel and start implementing it. This one will be quite complex, trust me. We're doing quite a lot of stuff here, a lot of animations, and a lot of different videos which we need to scroll through at the same time. So let's first wrap everything into an empty React fragment and then have a div right below. This div will have a class name equal to flex and items-center. Immediately within it, we want to map over all of our highlight slides by saying highlights slides like this, coming from /constants. So if you look into it, you'll notice that this is essentially an array of a couple of different objects, each one of which has an ID, a list of text elements such as the chip, the video, and the video duration. We'll use all of this information to display all of these videos one by one. And it's not just the video, it also has text. that we show alongside that video. So we want to map over those slides. And then for each one, we get a list, also an index. And then we automatically return something. When I say automatically return, I mean just have parentheses here and not curly braces. That means immediate return. For each one, we want to return a div, and we want to close it. That div will have a key equal to list.id, and it will have an ID of slider. Within it, we can have a div, which we need to close, and it will have a class name equal to video-carousel underscore container, and we can save it. So now if you scroll down, we cannot see anything yet, but if you type something within it, you can see test, 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 which means that we are properly displaying 4 different slides. Now, where we have the ID of slider, we also want to give it a class name equal to, on small devices, padding right of 20, and usually padding right of 10. That's just going to provide some spacing so you don't see the other slide while the first one is not completed. Within this div, we can render another div, and that div will have a class name equal to w-full, h-full, flex-center, rounded-3xl, overflow hidden, as we don't want to see those ugly scroll bars. We'll animate it to slide over different ones, and then bg of black. Now you can see this black rectangle where the video will go. So right within this div, let's create a video tag that will have a source within it, like this, and that source will have the src property of list.video with a type equal to video/mp4. And now we get our first video right here. But of course, a video cannot yet play. We need to make it play automatically. So let's give a couple of properties to this video, such as ID of video, so we can later on target it. Plays in line, like this, will be set to true. We're going to also give it a preload class of auto, muted, and that's it for now. Now, as you can notice, it's not going to start playing yet. That's because we want to play it using some animations. More on that later, but for now, let's create the layout around each one of these slides. We're going to go below this video and below one more div and create one last div that will make this slide. This div will have a class name equal to absolute, because we want to absolutely position that text on top of our video with a property of top 12, left dash inside of square brackets 5%, and the z index of 10. Within that div, we're going to map over our list text by saying list dot text lists dot map, where we get each individual text, and for each one, we automatically return a p tag with a key equal to, let's do text, and it's going to display text. You can see, enter A17 Pro, game-changing chip, groundbreaking performance. Let's style it a bit by giving it a class name equal to, on medium devices, text-2xl, usually text-xl, and font-medium. There we go. This is how it looks like. It's going to be much better once we actually start playing the video too. First, I'll create some refs or references to specific elements so we can keep track of the video we're on. I'm going to start by saying const video ref is equal to use ref coming from React, and at the start, it will be set to an empty array. I will repeat this 2 more times, call the second one video span ref, and the third one video div ref. We'll have to manipulate and play with a lot of these different elements. Now that we have these refs, let's also create a state for the video by saying use state snippet and call it video and set video, and at the start, it will be equal to an object. Don't forget to import useState from React. This video will have some properties like isEnd at the start set to false. Start play at the start set to false as well, right? The first one is not yet playing. We have to figure out which one is playing. So for each video, we'll have to know when to trigger this and when to turn it to true. Then we have the video ID at the start set to 0. Is last video will be set to false at the start, and then is playing at the start set to false. We'll need answers to all of these questions, and periodically we'll have to switch it on or off. Now, just so it's easier to work with these pieces of data, we can immediately destructure those values by saying const and then getting the isEnd, is last video, start play, video ID, and is playing, which is equal to video. We have essentially just extracted those values or destructured the values so we can then use them without saying video dot, video dot, video dot. Great. So now let's create a use effect so we can start playing those videos. This use effect is of course coming from React, so we have to import it, and it will be a callback function, and we of course need to have a dependency array. We will recall this use effect whenever the video ID changes or whenever the start play variable changes. So what will we do in this video? Well, first, we have to figure out where are we in our video playing journey. So we can say const current progress is equal to 0. And then we have to get the span element of the currently playing video by saying let span is equal to video span ref dot current. More on that later. Finally, if we have that span of a specific video ID, then we can start animating it. Here, we'll animate the progress of the video. Remember what that is? If I go to the finished website and reload, you can see how nicely this progresses for the entire video duration and then opens up a new one. So we'll do that soon. But first, let's just focus on getting the videos to play in the first place. To do that, we can say let anim, which is short for animation, is equal to GSAP, which is coming from GSAP, dot to, where we get a span and then the video ID of that span. And then as the second parameter, we provide all of the options, as you know. Options don't necessarily have to be just properties that we animate, like opacity or Y or X axis. It can also be specific functions, like on update, what will happen once the animation updates, which is a callback function. The second one we can have is on complete. What happens if the animation is complete? In this case, since we're working with a much more complex animation, we need to keep track of all of these values. But this animation specifically has something to do with the progress tracking, which we're not doing yet, so we'll get back to this very soon. For now, let's create another use effect on top of this one, and this use effect will deal specifically with the playing of the video. So it can be re-triggered whenever the start play changes, whenever the video ID changes, the is playing, or the loaded data. That loaded data is a new use state property, which we can create right here. Use state snippet, loaded data, set loaded data at the start equal to an empty array. More on this soon. So what are we going to do in this use effect? Well, here we can say something like if loaded data dot length is greater than 3, then if not is playing, we can say video ref dot current video ID dot pause. So if we came to the end and if we're no longer playing, then pause it. Else, if is playing is true, then if start play is also true, then video ref dot current video ID dot play. So we find a specific video we want to trigger and we play it. This by itself won't yet start our first video, and that's because we haven't yet given it any refs. So moving right here below to our video, we have to give it a couple more properties. First of all, let's give it a ref equal to. Here we're going to have a callback function where we get the element, and we want to say video ref dot current I is equal to element, like this. So we're finding a specific index in the video refs array and setting it to this current video element. Then on play, we want to call a callback function where we want to set video, where we get previous video information, so prev video, and then based on that information, we automatically return, so you have to do parentheses and then curly braces, the spread of the previous video, so prev to get everything we have there, but this time we turn on the is playing to be equal to true. So on play, we spread all the information about the video, but we set the is playing to true. I know this is getting a bit more complicated, so if you have already gotten stuck or if something is not clear, don't worry, you can code it with me. If it doesn't work like it should, at the end of this video carousel portion, I will also provide you with the complete code for the video carousel. So even if something breaks during the process, you still got to watch it, learn from it, and then you can paste it, have it working, and then explore exactly what we're doing. Now that we have only the video, it's kind of hard to see when the next one should be playing or what's happening with the video duration. So what do you say that we also implement the JSX for this progression tracking and this button too, which we can use to pause it, and then we can continue with getting the video to play. So with that in mind, we can scroll down, go below here where we're rendering text, go all the way until the bottom, and then here we want to create another div. This div will have a class name equal to relative, flex center, and a margin top of 10 to divide it a bit from the content above. Within it, we want to have another div that will have a class name equal to flex-center, padding y of 5, padding x of 7, background gray of 300, backdrop of blur, and rounded dash full. This will create this rectangle pill-like shape so we can track our progression. Within there, we want to go video ref dot current dot map, where we get each video, but we don't need to do anything with it, so we can just call it underscore, as it's usually the practice, and then you can also get the index. For each one of these video refs, we want to immediately return a span element, and that span element will have a key equal to the index, and we also need to give it a ref. This ref will also be equal to a callback function where we get the element, and then we set video div ref dot current index is equal to element. So we're going through a couple of these, and whenever we have a new video, we add it to this video div ref array. We also want to give it a class name equal to margin x of 2 to create some margins, w of 3 for width, h of 3 for height. You can see how the pill is changing shape. bg gray of 200. There we go. Now we have 4 of these different dots. Rounded dash full, relative, cursor dash pointer. Within each one of these, we want to create another span element. That span will have a class name equal to absolute, so it will be absolutely positioned. H dash full for full height, W dash full for full width, and rounded dash full. To this one, we also want to give a similar ref as to the above one. So we can simply paste the ref and change it from video div ref to video span ref. And we can self-close this span right here. There we go. That should look something like this. Wonderful. And finally, let's create the button to pause or reset it like we have it right here. While it's playing, you can pause it, and else, if it's done, you can reset the progress. So going below this span and below one more div, we can create a button that will have a class name equal to control-btn. You can see the button appear right here. We can render an image, an img tag right within it, with a source equal to if is last video, then we render the replay img coming from utils, else if it's not playing, so if not is playing, then we render the play image, else we render the pause image. So we're using a double ternary right here. For the alt property, we can check if it's the last video, then we say replay, else if it's not is playing, then we say play, else we say pause. So this little button has 3 different functionalities: play, pause, and replay. And let's give it a click. By saying on click, we want to check if it is the last video. Then we can call a callback function, which we will call handle process, and pass it a string of video reset. This will temporarily break our application, but don't worry about that. Then, if it's not is playing like this, we can then call another callback function, calling the same handle process function, but this time with the play action. And for the last time, we're going to call the same handle process, but this time with the pause action. So now you might be wondering, what is this special handle process function? And from where will we import it? Well, this is a function which you will create. So let's scroll up right here, and let's create it right below this use effect by saying const handle process, which accepts the type of the action we want to make and the index. And we're going to open up a switch case. So I like to use a switch whenever there's multiple cases. So switch based off of the type of the action. And if the case is video end, in that case, we're going to set video state by getting the previous video state, spreading it out by saying ... previous video, is end we'll set to true, and we're going to increment the video ID by setting it to i+1. Looks like I missed a closing arrow right here. There we go, now we're good. So this is if we're at the video end. And don't forget the break. The second case is the video last. So if we're at the last video, but not yet end, here we also want to call set video, and we're going to also get the previous video, which I guess we can shorten for just previous video right here, and then we want to immediately return something by first spreading the previous video and then adding the is last video to true because it's the last one. Of course, don't forget to break it. Let's add another case, which will be video reset, where we can also basically duplicate this set video. And instead of saying is last video, we will say is last video is false, and we're going to reset the video ID to 0. Let's break it. And finally, and most importantly, we have a case of play. So we want to play the video. And here we can again duplicate this set video, paste it below, and say is playing will be the opposite of previous dot is playing. And that's basically the only thing we want to do. We want to break it. And at the end, default, we can return the video. So here we handled all of the different actions that we could ever do with that video. That is great, but still not a lot is happening on the screen, right? So let's use GSAP to bring it all to action. Right at the top, after we destructure everything from our video, we can use the use GSAP hook like this, coming from GSAP React, where we provide a callback function. And here in the dependency array, we're going to add the isEnd and the video ID so that we update stuff whenever the video ID changes. Here, we want to animate the video to play when it is in the view by saying gsap.to. We're going to select it by the ID of video, and we want to provide it a couple of things. First, we're going to provide it a scroll trigger like this. So once this thing is in view, then we trigger it. Once what is in view? Well, the video ID. What do we do then? Well, toggle actions, so do something, and we're going to say restart the video. This is when it first comes into the view, and there are many different cases when it comes to the view from the top or from the bottom. In other cases, for now, we're going to say none, none, none. We're only interested in making it play once it first comes into view. After the scroll trigger, once we're complete with the video, we want to have a callback function, and we want to set video to be equal to, where we get the previous one, immediate return, pre by spreading the previous state, start play will be set to true, and is playing will also be set to true. Now, if we save this, this by itself won't yet start playing the video, which is fine, but what will is the use of our loaded data. So the reason why we have this loaded data is because here in the original use effect, we are checking if the loaded data exists, and only if it does, only then do we start playing. So what we have to do is create a new function right here, const handle loaded metadata equal to, and this function will accept the index as well as the event we pass into it, and it will simply call the set loaded data. It will take all the previously loaded data, so pre, and it will automatically return an array pre, and then the new event we have added. With this handle loaded metadata, we can now attach it to our video player. So going to the video, we can say on loaded metadata. And basically what this means is this will get triggered with the event once the metadata of the video has loaded. So once it got the data, we get that event and we call the handle loaded metadata and pass the index as well as the event. This handler will call this function, which will in return call our state setter, and once it's in there, this use effect will trigger the video play. So let's save it and reload. And as you can see, the video is now playing. Let's check that out one more time on full screen. So if we go here, on full screen, you can also see the videos which will soon play. So let's reload. And there we go, the video starts playing, but nothing is happening with the animation here. And once it ends, we're not seeing the next video. So let's make that happen as well. And once again, if you reach this point and if you're watching this, and if this part is very confusing, don't worry about it. At the end of this entire segment, I'll provide you with the entire video carousel code, so you'll be able to continue having the complete working code, but still you will have learned a bit about how setting up more complex video animations works. Now that we've got our first video playing, let's also implement the way to track the progress of that video. We can do that right here. I believe we even added a comment for ourselves. There we go. Animate the progress of the video. So here we can say const progress is equal to, and we can use the math.seal method and then get the anim.progress. So this is directly built into GSAP, which allows you to get the progress of the animation. How cool is that? And then you can multiply that by 100 to get the percent. We can say if progress is not equal to current progress, then we want to update it by saying current progress is equal to progress. And of course, this current progress has to be a let. And then we use a GSAP.to functionality where we target a specific video div ref, which is the container for this dot, which will soon turn into a progress handler, dot current of the specific video ID. And then we're going to modify its width by saying width is window.inner width is lower than 760. If that is the case, then we're going to make it something like 10 VW for mobile. Else, if window.inner width is lower than 1200, then we're going to make it something like 10 VW. That's for tablet. And else for laptop, we're going to make it 4 VW. So if we do this, you can immediately notice how it expands, which is great, but still we have to animate the progress bar. So let's go below and say GSAP.to span of that specific video ID. We're going to modify the width, and we're going to do it dynamically by setting it to current progress and then percent, like this. And we're going to change the background color to white. So if we now save it, you can see how nicely, if you reload, it animates and moves further. Of course, now it only lasts for the duration of the animation, which is a couple of seconds. But now we want to actually modify the duration to be exactly as the duration of the video. So let's navigate to our onComplete and check if is playing. In that case, we want to say GSAP.to video div ref dot current video ID. We're going to modify the width to 12 pixels. So only if it's playing it's 12, usually it's going to be just a dot. So on complete, we bring it back to a dot. And also GSAP.to, we're now targeting the span of a specific video ID, like this. We're going to change the background color to be equal to hash AF, AF, AF. Of course, we must not end this right here. We must end it right here below. So if we now save it, you can see how quickly it starts and then gets back. Let's go below this onComplete. So that's going to be all the way here, and also exit this animation. So exit curly brace and parenthesis. Here, we want to say if video ID is equal to 0, then we want to restart the animation by saying anim.restart. So this is a utility handler given by GSAP. And finally, now we want to modify how long the animation lasts by saying const anim update, which is going to be used to update the progress bar. Here, we can say anim.progress. And bear with me, we'll have to do some math. We have to get the video ref dot current video ID divided by highlights slides video ID dot video duration. So we divide those 2 times, and that should give us the progress. Then we go down and say if is playing, then GSAP.ticker, and ticker is used to update the progress bar, .add anim update. Else, if it's not playing, GSAP.ticker.remove anim update. And this anim update is coming from here, but it needs to be one scope below so we can actually access it there. But here we cannot access the anim, as I can see. So we have to move all of this a bit to the top right here. So there's one closing here, and then we have these 2. So now if I save it, you can notice how it expands and it's immediately all white, and it stays that way. Of course, this is still not the same as on the finished website, where it slowly does it and then moves on to the next one. So let's fix it. One thing we have to do is we have to give this video a few more properties, or rather a few more handlers. We have to know when will it end. So we can say on ended. We're going to open up another callback function, and we're going to check if the index is not equal to 3. Well, in that case, it's not yet the video end. So we can call a ternary operator and call the handle process where we pass the video end and then a specific index, so we know which one will we end. And if we are at the third one, we call the handle process and call it a video last, so we know that we need to restart. In this case, this can be an immediate return, so we don't need curly braces here at all. And of course, we don't need 3 equal signs if it's inequality. If we save it now, we should be much closer to actually transitioning to the second bar, which you can see it actually opens, and it should go to the third one as well. But the videos are not yet reflecting that. So let's go back to our animations right here to use GSAP. That is here at the top. And we're going to add a second GSAP animation by saying GSAP.to. And here we want to target the slider. I believe we have given it an ID of slider. Yes, you can see right here. And we will modify it like this. We will apply a transform property where we will use the translate x. And then we're going to make this a dynamic template string, and we're going to move it by -100 times the video ID. So for each video, the first one is going to be 0, so it's going to stay there. For the second one, it's going to be 1, 2, 3. And as we update this video ID, we're going to modify the percentage of how much we move away. So that way, new videos will start showing up. And of course, we have to properly close it. If we save this, we're getting closer, but not there yet. We can also modify the duration to 2 seconds and save it and reload. We get the first video playing. It's looking good. The second one, but still nothing happens. In this case, we want to use a special ease function. And what are these ease functions? Well, ease functions allow you to specify how you want your animation to happen. It can happen faster at the start and then slower at the end. Or you can give it some power at the start. You can also make it elastic like this. You can play with it and do whatever you want. Quite interesting, right? In this case, I found the power to dot in out to work the best with our video specifically. Great. We're getting very, very close to having all of this working. And I think I know why these are not getting properly cleared. If we scroll down all the way to where we're updating the specific animation, here we are dividing just the video ref with the video duration. Doesn't make too much sense. What I wanted to do instead is get the current time of the video and then divide that by the video duration. Only like that, it will actually be able to know how far did we come. So if I reload now, you'll be able to see that our video tracking progress updates are now working properly. They go one to another, and soon we'll be able to stop them as well. And the reason why we're not moving from one video to another right now, believe it or not, is a simple typo. Instead of saying % and then closing the parenthesis right here, I first closed it and then added a % sign. So if we just modify these two and reload the screen, we get the first video playing, the progress works, and then it still fails because I have an extra curly brace. So if I remove that extra curly brace, now it works. As you can see, it goes to the last one. It allows us to reload or restart from scratch, goes first, second. The pause doesn't work right now, so let's fix it. We are pausing within our handle process where we have the play but I don't see the pause right here. So basically, we have to copy this play, and I think just renaming it to pause should do the trick because we're doing the toggle right here. Is playing or is not playing? So if we reload, so if I click pause, it works, and I continue. This looks and feels wonderful. It's not just the videos that make it special. It's the pieces of text, it's the progress bar loading, and this button right here. One last thing we can do is I noticed that for some videos, we need to apply a specific class name right here. So we can say class name to the video where we open up a dynamic block of code and say if list.id is equal to 2, then we can translate x44 and close it. And we don't need the other, so we can just do the end. We can close it. And then we can also say pointer events none, like this. There we go. If we now save it, this looks great. And as I promised, if this is still not working for you, the full video carousel will be added to that README so you can copy it and override this code right here. If it didn't work before, then it definitely will work now. So with that in mind, let's expand it to admire it in its full glory. I'm gonna scroll all the way to the top to check out our hero. And now I'm gonna bring the videos in view. It nicely opens up. We get the second video playing too. We can pause it, we can play it. It's gonna go to the third one. And finally, we can also restart. How cool is this? I know this was a more complicated one, quite a complicated component to implement. 200 lines of complex logic for video refs, getting the progress bar to working, and more, but you got it. Even though it might not have worked at the start, you understand at least a bit better of how you would approach something as complex as this, and that counts too. So great job on completing the video carousel, and with it, completing the highlights section of the video. I hope you're excited for what's to come because the next thing is gonna be the 3D model. Look at those reflections, look at the quality, you can change the color, and don't forget, you can change the size. So let's go ahead and implement the 3D model next using Three.js. Oh, and just so I don't forget, if you didn't download it at the start, we have created a special Three.js and GSAP guide. Specifically, I'm referring to the GSAP part right here. If what you have now developed was a bit tough and complicated, I strongly advise you to just go through the guide, take it step by step, and take the base concepts in, so then everything else will start making so much more sense. I have also included some special tips and tricks in there, so GSAP Animations will be simpler for you in the future. Great. With that said, let's get back to the 3D model. So to get started with our 3D model, let's create a new page right here, or a new section called model, like this. And of course, we have to import it from somewhere. So let's import the model from components model. And of course, therefore, we have to create it right here by creating a new component called model.jsx with RAFCE right within it. Now, back on our localhost 5173, we can see the model right here at the bottom, which means that we can get started with developing it. We're going to start as we usually do by turning this div into a section, and we're going to give it a class name equal to common-padding, which will apply some common padding on all the sides. We can also create a div that's going to have a class name equal to screen-max-width. And within it, we can create an h1 that will have an ID equal to heading, because we're going to animate it very soon. And it will have a class name equal to heading, or rather section-heading 2. And it can say something like, take a closer look. Look at what, you might be wondering? Well, of course, our model. Now, we cannot yet see this piece of text right here, and that's because we will animate it using GSAP. So in this case, we can scroll all the way to the top of this model and say use GSAP coming from GSAP React, which we simply call like a callback function right here. And we can specify an empty dependency array. Right here, we can simply say gsap.to. Of course, GSAP needs to be coming from GSAP. And we can target the heading as we're used to. And then we can also create a new object saying what we want to animate. We want to make it come to the position of 0 and bring the opacity to be equal to 1. That way, our header will be showing. There we go. Take a closer look. Now we can scroll below this h1 and create a div which will serve as the container for our model. So let's create a new div that will have a class name equal to flex-call, as we want the elements to appear in a column, items-center, and margin top of 5. Right here within that div, we can create another div that will have a class name equal to w-full for full width, h-75, which will look something like this for the height, and we want to specify 75 VH, which means vertical height. So that's about 3/4 of the screen. On medium devices, we can increase that a bit by saying h-, and that's going to be 90 VH like this. Overflow hidden, so there's no scroll bars, and relative like this. Now we cannot yet see anything in there, but we have created some space to present our model within. So to create our model or to show it, we of course will render another custom component so we can separate the logic of the model, of showing that 3D model, from this entire section. So what we can do is create a new component called model view.jsx. And for now, we can simply call RAFCE within it. And now we can use that model view and render it as a self-closing model view component like this. There's two different iPhones that we want to show here. There's going to be the small one and the big one, as you can see right here. And we'll want to render both of them. So for that reason, what we can do is we can immediately create references for each one. So let's go to the top and let's create a new use state snippet. And this one will be size, set size like this at the start equal to small. So we need to be able to choose which one we currently want to look at. And of course, we need to import use state from React. Then we also want to get all of the other model details for the small or the big. So we can create another use state snippet and say model, set model, and at the start, it will be equal to an object containing the title, which can be something like iPhone 15 Pro in natural titanium. We can also specify different colors. So we can do that an array of hash 8F8A81 like this. We can also do something like hash FFE7B9. I found those values to work the best. And hash 6F6C64, just so we have some colors to choose from. And we can also specify the image. This one will be yellow image, which is coming from the utils. This is just the default state, which we'll be able to modify later on. And of course, this model has to start with a lowercase m, like this. Now, there is still a bit of setup we have to do. We have to set up camera control for the model view. So we have to specify camera controls as well, which is interesting. And we will do them like this. Const camera control small will be equal to use ref coming from React. And we will duplicate that and create a camera control large. We need to have a separate camera ref for each one of these two models. And of course, we use the size to simply say which one are we currently viewing. Here, we specify the model details. these are the different colors for different meshes, which we will use within our 3D models. And here we add the texture, which we're gonna use. You can see how it looks like here. It's a JPEG, but it doesn't allow me to currently view it, but you can view it within your just typical Finder or File Explorer. So with that in mind, we have created camera controls for this model view. And also we need to create another ref to keep track of the model to access its properties when animating. So we can do that by saying const small is equal to use ref, where we can say new 3.group like this. So we're creating a new group of Three.js elements. And this 3, of course, has to be imported from somewhere. So for the first time in this video, we have to install Three.js. Let's do it by saying npm install 3, as well as add react-3/dray and add react-3/fiber. These are utility helpers that make the use of the Three.js library easier for React applications. So let's simply import this 3 coming from 3. We can do that at the top by saying import everything as 3 from 3. There we go. And we can duplicate this and also create one for the large model. Another thing we'll have to keep track of, and I know there's a lot of things to keep track of. So this is the camera control. This right here is the actual models themselves. And then we need to keep track of the rotation value of each model. By saying const, we can say small rotation, set small rotation is equal to use state. And at the start, it's going to be set to 0. And we can modify this as well and set large rotation as well. So large rotation and set large rotation. We have to keep track of the values of both of these models at all times so that if we rotate it, we can see and know where it is, go back, bring it to 0, and then show the other one. Great. So this was a bit of a setup, I know, but now we can actually pass all of the important information to our model view, which will soon render that model. So let's pass it the index. This one will of course be 1 because it's the first one to show. Let's give it a group ref, which is going to be equal to small, a GSAP type of view1. So this is the first one. Control ref for camera control of camera control small. Set rotation state is going to be equal to set small rotation. And finally, we want to pass the item, which will be equal to the model. This model is universal, as it can be a big one and a small one, depending on what we choose in the state. And also, we want to change the size right here by tracking what we have in the state. Great. Now, if we go back to our current application, we can still see just a model view, nothing more. So now let's duplicate this below and let's make it work for our big one by saying index is 2, large, view 2, camera control large, also set large rotation, and then the model and the size can remain the same. Now we can see 2 model views, and soon enough we'll render those models. But for now, we first have to show the canvas. So going right here below, we can render a canvas component coming from React 3 Fiber, and within it, we can render the view.port like this. And this view also has to be imported from React 3 Dray. Viewport is a way to render multiple views of a model in the same canvas. Doing this will allow us to animate that model. Now, let's also make this canvas full screen. So we can give it a class name equal to w-full and h-full. And we can also style it a bit by giving it a style property that can be position is fixed, top is 0, bottom is 0, left is 0, and right is 0 with an overflow of hidden. There we go. So we're just resetting the positioning. And later on, we'll also need to get access to the event source. And you can do that by saying event source is equal to document.getElement by ID. And we're going to get the root right here. This is useful when you want to interact with the model that you work with. Now, this temporarily broke our application. So let's go to inspect and go to the console. And you can see right here, it says uncaught type error, document.getElements is not a function. This right here should have been getElement by ID, as it can only be singular. So now we are back into the game. Before we start working on these 3D models, let's also show some additional information, such as the title, colors, and the sizes. That way, as soon as we show the model, we'll be able to play with it and modify it. So going back right here, we can go below the canvas and below one more div and create another div. This one will have a class name equal to margin X of auto and W-full. Right within it, we can create another p tag that will say model.title. And immediately you can see iPhone 15 Pro in natural titanium. And we can also style it a bit by giving it a class name equal to text-sm, font-light, text-center, and margin bottom of 5. There we go. That's better. Let's also create a div below that p tag, and that div will have a class name equal to flex-center, and right within that div, we'll have a UL that will have a class name equal to color-container. So within here, we want to map over all of our colors. So we can open up a new dynamic block and say models.map. And then to get access to these models, we're going to import them from constants. And you may be wondering, what is this? Well, it's nothing more than an array containing a couple of objects where each one contains some colors, different meshes, and also the title. That is it. So we want to map over those models and get each individual item, and then also the index of that color we're showing. And for each one, we want to automatically return an li, which is a list item, with a key equal to I, a class name equal to W-6, H-6, rounded-full, and margin X of 2. And then most importantly, we want to give it a style property of background color will be set to item.color 0. So this will be coming directly from that object within the models array. And then we can also give it an on click. So once we do that, we want to set the model like this and set the model to be that specific selected model, be that blue, yellow, or whatever other color. And we can immediately close this li like this. If we save it and scroll down, you can see these 4 different beautiful colors appear right here. And we can also add a cursor dash pointer so that the user knows that they can actually click it. There we go. It's not just for the show. Let's also go below this UL and let's create buttons for managing the size. We can do that by saying button with a class name equal to size-btn-container. And within it, we can simply open a dynamic block of code and say sizes.map, where we can destructure the label and the value of each size, and then automatically return a span that will have a key equal to label, and it will simply display the label as well. Of course, the sizes have to be imported from the constants. Now you can see 6.1 and 6.7. Let's style it a bit further by giving it a class name equal to size-btn. That's much better. And let's also give it a style property equal to background color. And here If the size is equal to the selected value, then it can be white, else it will be transparent. That way we'll know which one is currently selected. And also the color, if the size is triple equal to the value, then it will be black because it has the white background, else it will be white. So now we can see which one is currently selected. And let's also add an onClick where we can call a callback function and set size to be that specific value. So now if we save it, you should be able to click and move between those two states, as well as select different colors and immediately see that the title changes as well. That is amazing. But of course, that's nothing without the models, which are the main star of the show. So we have to scroll all the way up and navigate into our model view. And that way we'll be able to make our colors and sizes make changes to the 3D models we'll display on the screen. So first things first, let's accept all of the props we're passing into this model view component. We're going to get the index, the group ref, the GSAP type, the control ref for the camera, set rotation size, the size, and the item. Then we want to create a viewport for the model by wrapping everything in a view coming from React 3.js. Each view has to have an index, so we know which one it is, and we can pass it from the props. The first one will have an index of 0, and the second one of 1. We can also give it an ID, which will be a GSAP type, also coming from props. And let's also style our view a bit by giving it a class name. And just so we can initially see it, I'm going to give it a border of 2 and border of red 500. So now you can see where it is positioned. Right now, it is just a line in 2D, but if I give it a W full and H dash full, it will take the full height of the screen. Also, we need to hide it if we're not showing it currently. So we can turn this into a dynamic template string like this and properly close it. And only if index is equal to 2, then we want to say right dash minus 100%. That's going to look like this. Else, nothing. So this way we can swap between the left and the right one. Next, we want to play with the lighting a bit. And the first source of light will be the ambient light, which lights up all the objects in the scene equally. So we can say ambient light, and we can give it an intensity of about 0.3. And right now, it looks like it cannot properly read the light. Unknown property intensity found, but we'll fix that soon enough. Let's focus on what matters, maybe even more than light. Well, who knows, because we cannot have a camera without light, right? But still, we need both the camera and the light to get the picture. So we'll use a type of camera that simulates the perspective of the human eye, and that is called the perspective camera, coming from React 3.js, like this. We can give it a make default, so this is the default camera, and give it a position that is an array of 0, 0, 4. So now we have the camera, but it's still dark. We can then create some more custom lights by creating a new component called lights.jsx. And from the README of this project, you can copy the lights.jsx component and paste it right here. You'll soon be able to notice that this contains the environment and a couple of different lights we're using. The reason why I decided to provide these lights to you is because I was playing a lot with figuring out how to make this look the best. And with these light formers, I managed to create custom lighting that are properly light up our 3D scene with different lightings, intensities, positions, and more. And once again, just to remind you, more details on these light formers, custom lighting, and 3D modeling with Three.js in general, you can find in the guide. So with that in mind, it looks like that even though we have imported these lights right here, still our Three.js has some trouble figuring out whether they actually work or not. And this could be just an ESLint issue. So let's go back right here and let's call our lights property like this by importing those lights at the top by saying import lights coming from /lights. And if we scroll down, it's still quite dark out there, but don't worry, as we'll figure it out soon. Right below the lights, I'm gonna call a suspense, which is used to provide some kind of a loader until the model loads, like this. So you can give it a fallback, and then within the fallback, you can define something that's gonna load, like maybe a div that's gonna say loading. Later on, we'll make a custom loader, but for now, this will be good enough. The most important thing is now rendering the iPhone model. Now, the way we can get to that iPhone is by checking out our public models, and then we have our scene.glb, which contains the iPhone model. Now, I have found a phenomenal GitHub repo that turns GLTFs into JSX components. So just click this link in the description, and then simply drag and drop your scene by revealing it in Finder or opening in Explorer, and then simply drag and drop it in. What it will do is it will automatically render it for you in the browser so you can check it out, which is very, very cool for testing out different models. But then even more importantly, what we care about is that it generated an entire 3D JSX file with all of the meshes right here. So let's simply copy that entire thing. I think we can do it somewhere here. Now here we can play with the model even more and modify the shadows, the types, and stuff like that. But in this case, I will just keep it as it is and import this entire thing. Copy it, and I want to create a new component called iPhone.jsx and simply paste everything I have here. Don't worry about these ESLint warnings for now. With that in mind, let's go back to our code. And right here within the suspense, let's render this iPhone model, which of course has to be imported at the top by importing iPhone from iPhone, which will broke the screen because if you go into that iPhone, you will see that right now it just exports it as a function instead of saying something like function model. And then at the bottom, we can say export default model. That way we have something to import within our application. And of course, since it doesn't know where we put this scene, we have to say that it's coming from models scene.glb. And if you scroll up in this same file, you'll be able to see that here we also have to say models scene glb. If you do that, our app is back to the working state. And if we scroll down, you can see a very, very tiny iPhone model in the middle. I'm gonna zoom it in and you can barely see it. So now let's actually play with the lights, the positioning, the camera, and let's make it bigger. I'm gonna go back to our model view right here, close everything else so we can just focus on it. But before that, very quickly, let's get rid of these ESLint warnings. They're okay in this one, but under lights, they are quite ugly to look at. And especially within our iPhone model, here they're all over the place. So to fix it, you can go into the ESLint RC, and right here, you can add a plugin called Add React-3 and save it. That way, ESLint will automatically know that these are real properties that exist and that you can call. As you can see, now it knows exactly what intensity is, and it's no longer complaining. While we're here, let's also remove this ugly border, and let's make this iPhone model the star of our show. I'm going to wrap this entire suspense into something known as orbit controls, which allow us to move the camera using the mouse. So I'm going to say orbit controls coming from React-3 and that will be a self-closing component right here. So we don't yet have to wrap it, but we do have to wrap suspense within something known as a group. So a group containing the suspense and the iPhone, like this. This group will have a ref equal to group ref. It will have a name if the index, like this, is equal to 1, then it's small, else it's going to be large. And we can also give it a position, which is equal to an array of 0, 0, 0 to position the model in the center of the screen. Now let's play a bit with orbit controls. We want to make our orbit controls the default way of traversing over our model. We want to give it a ref equal to control ref. We also want to give it enable zoom to false, as we don't want to zoom it in, we just want to move it around. We're going to also disable panning, so we cannot, once again, kind of move it around. And we're going to modify the rotate speed to about 0.4 so that it's slow and steady. Then we're going to provide a target to target the center of the screen by saying new 3, and this 3 has to be imported at the top by saying import everything as 3 from 3, like this. And now if we scroll down, we want to call it and construct a new vector like this, vector 3, and give it 0, 0, 0 as x, y, and z axes. So we position that in the center as well. Finally, once we stop rotating, we want to get the angle of the camera so that we know where we are. So we can say on end, we can call a function that's going to set rotation angle, or rather set rotation state, I think we called it, to control ref dot current dot get azimuthal, like this. It's a weird one, I know, but we need to get this specific angle to know where we are in the space. And soon enough, we'll be able to rotate our iPhone. But for now, let's scale it up so we can actually see it. We can do that by giving it a scale property and saying if index is triple equal to 1, then we want to say 15, 15, 15. Else, if it's the big one we want to show, we're going to make it 17, 17, 17. There we go. That's more like it. And you can see that the orbit controls work, because if we remove the orbit controls or if we comment them out, you cannot move it. It stays stuck in place. So these definitely come in handy and allow you to move the model. Now we can also provide the item, which contains all the information about that model, and the size, which also contains the information about the size. So this is our model. As you can see, we have it here. And if you click here, it doesn't quite yet change the color, but it will soon if we dive into it and create something known as a texture by saying const texture is equal to use texture coming from React 3.js, and we want to pass it props.item.image, img, like this. This contains the mesh we want to cover our phone with. Then we can use a use effect like this, and we're only going to call this when the materials, or the props.item change. So once we make some kind of a modification to these buttons that change the colors and the size. Within here, we want to call the object.entries to get the key and the value pairs of all of our materials. And we want to map over each one of these materials where we get an individual material, and then we check if that material exists. We can check that by checking if material 0 is triple equal to a specific string that we can then compare with a specific color. Now, these are basically strings of IDs that contain about 10 to 15 characters, and I definitely don't want you to type all of these by yourself. So in the README down below, you can find those 5 or 6 different material colors. As a matter of fact, you can find the entire use effect belonging to the iPhone model. So copy it and paste it right here. As you can see, these are the material names that can be changed, and they modify the color. So material1.color is the new color coming from the props which we choose on the screen. Now we get an error because we didn't import useEffect from React, and we also need to import 3. So we can do that by saying import everything as 3 coming from 3. And if we save that, now we're back. And would you look at that? We have a yellow iPhone and it actually looks quite good. There we go. We can change it to white. And now our picker works as well. This is wonderful. But we're going to make it even better. If we go to the finished website, you can see that on the blue iPhone, we have a very vivid blue color. If we change it to yellow, it is completely yellow and completely dark. Whereas on ours, currently, yeah, sure, it does change a bit, but for white color, it just looks too white, right? So what are we gonna do is take the texture from this image and then apply it to this specific front portion of the screen. And the way I found it is I used that same app that generated this JSX, and then there I inspected to see which specific material do I have to apply that texture to. And you can use a Control or Command F and search for EIU and find it here. You want to expand this mesh, and then within it, give it a mesh standard material with a roughness of 1 and a map of texture. That way we can apply black for black, this one for the white, this one for the yellow, blue, and so on. So you can see that now it makes complete sense and it looks much better as we're applying a custom texture for each color. Great. So with that in mind, we can exit this iPhone and we can finalize our model view by providing a proper loading. Because now if I reload, this loading doesn't look too good. So instead, let's create a new component called loader.jsx, run RAFCE, and then import it right here as a custom component. There we go. And of course, we have to import it at the top by saying that it's coming from loader. Now, if we go to the loader, now if we reload, it will break because don't forget, we have to wrap it in HTML so that it knows that it's not 3D. So we need to wrap it in HTML. And this HTML coming from React 3.js. And then we can give it a div, which we can absolutely position by giving it a class name of absolute, top 0, left 0, W full, H dash full, flex, justify dash center, and items dash center. Within it, we can render a new div that will say something like loading ... And we can also style this a bit by giving it a class name of W-10VW, H-10VW, and rounded dash full. Now, if I scroll down and reload, it's looking just a tiny bit better, but actually I created this loader file to give you the opportunity to play with some interesting and exciting models. Maybe search the internet for some exciting 3D models of different loaders. And once again, a complete list of websites where you can find different 3D models can be found in our Three.js guide. So download it, check it out, and do something interesting with this model. And once you do that, go on LinkedIn and X and tag us on there because I would be more than happy to share your work. With that in mind, you can see that there's only one property that we didn't use, which is the set rotation size. And that's because I misspelled it. It was supposed to be set rotation state, which we are using right here below. On end, we properly set the rotation state. So with that in mind, let's go back to our, that's going to be a model.jsx. And right now we have some fixes to make. You can see that our second model, which is the big one, is also visible on the bottom. And if I click right here, nothing really happens, right? So let's play with GSAP where for the first time ever, we're combining GSAP animations with Three.js models to make something truly exciting like this thing right here, where it rotates and we get the second model. To make that happen, we can scroll all the way to the top, create something known as a timeline. We can call it TL for short and call it a GSAP.timeline so that we can move across that timeline. Then we want to create a use effect like this. And it's only going to change when the size changes. Here, we want to check if we are going to trigger the size is equal to large, in which case we're going to do something, or if size is triple equal to small, when we can do something else. So now we're going to do a special kind of animation, which is a timeline animation. So it looks like this broke our application, most likely because we haven't yet imported use effect from React. Yep, that was it. And now let's create a bit of a more complicated animation. Since it will be a bit more complicated, what do you say that we extract its logic to another file? We can create a new file within the utils folder, which we can call animations.js. Within here, we can say export const animate with GSAP timeline. And this is a special function which we will call. Now, let's first talk a bit about what a timeline even is. A timeline is a powerful sequencing tool that acts as a container for tweens and other timelines, making it simple to control them as a whole and precisely manage their timing. Without timelines, building complex sequences would be far more cumbersome because you need to use a delay for every animation. Like this. You apply delays, wait, and so on. But with a timeline, you can specify exactly what you want one after another. But to make that happen, instead of calling gsap.to, you first create a timeline and then call the timeline.to, exactly like what we have done right here. So what we can do next is we can call this animate with GSAP timeline right here. And of course, we have to import it from utils animations. And we want to pass a couple of props to it. We're going to pass the timeline itself. We're going to pass the small model right here, the small rotation, as well as the view1 ID and the view2 ID, so we know when to move around. And you might be wondering, why are we doing small for the large one? Well, if the size is currently large, we want to animate it to the small one and vice versa. Also, we're going to give it an object of transform where we're going to run a translate x of -100%. This will remove it from the view. And we can also provide a duration of about 2 seconds. So what we're doing here is we get the current value of the small rotation. Then we rotate the small model by the value stored in that rotation. We animate the small model view to the left, and we animate the large model view to the center. But if the size is small, we're going to repeat the same thing right here, but we're going to display the large model and the large rotation. And we're going to animate from view 2 to view 1, and the translate x is going to be 0. There we go. So now we're passing all of the necessary props into this animate with GSAP timeline, and we can accept all those props right here. First, we passed in the timeline, then the rotation, ref, then the rotation state, then the first target, then the second target. These are view 1 and view 2, and then all of the animation props. Now that we have these, first we can call the timeline dot to, and we want to go to rotation ref dot current dot rotation. So we get a specific rotation, and we modify it by saying y is rotation state, duration is 1 second, and ease, I found this one to work the best, power2 dot in out. Right below that one, we call the timeline to once again, and this time we timeline to the first target, and we spread out all the animation props. So these will be the things like Y, duration, and more. So animation props coming from the props, and we can provide the ease of power2 dot in out. And also after that, we can provide a string of the lower than character. This symbolizes to insert the animation at the start of the previous animation. Finally, we can duplicate this one right here below and say timeline 2, second target, same thing, and everything else will be the same. So we animate from the first target to the second target. Now, if we save this, you can see that something started happening. They're moving. So if we select the small one, we get it back. If we select the big one, they're both gone. Now, let's see why here we have 2, and on the other one we have no models at all. Well, we can go to our model, and let's go directly into the model view. And here is where we're messing with which one are we showing. So basically, we modified the right position of one to basically get it off of the screen. But this right 100 is not going to work if it's not absolutely positioned. So here we can add position of absolute, and now they show one on top of another. Look at this. This is looking a bit weird. Let me reload. Yeah, there's still one on top of another. And that's because this right is not getting applied as it's outside of the dynamic block. So it needs to be within that dynamic block. Right here, if index is 2, then apply right, else apply this one. There we go. So now it's hidden, and if we go right here, it's showing. This is wonderful, and you can see how nicely it rotates. Like if you mess with it, it's gonna rotate back to the starting position and then move away. This means that our models are now great. We can modify the colors. Notice how the screen also changes, and you can go back to the different one that also changed the color. The meshes, the textures, the lighting, it's all looking great. And now that we can actually see the model, we can also play with the intensity a bit, like bringing it to 0.5, maybe bring it to 5. There we go. Now you can notice a big difference, or even 10, right? Now everything is very, very light, no matter which color you choose. So the colors really pop. But to get that realistic look, I kept it very, very low to 0.3, and that way you can really see the titanium coming out of this iPhone. But of course, this is something for you to play around with. You can modify the perspective camera, the lights, and so much more. That's the beauty of Three.js, learning how to navigate your way around the 3D world. And of course, if you want to learn a bit more about all of the different types of lights that exist, all of the different cameras that exist, and all of the other properties that you can use to mess with your models, definitely check out our guide, which is linked down below. With that in mind, let's close our model view, animations, and model, and let's expand our browser to full screen. I'm gonna scroll up and reload, and let's see how all of this looks like in full screen. We have this beautiful titanium iPhone 15 Pro. We scroll down. This was a tough one, right? The highlights section with animated progress tracking bars. This looks and feels good. We can also pause it, and we can scroll to reveal the model. Now you can move it around, see how it looks like in different light, and make a decision on which one you want to buy. It's no longer, should I buy it or not? It's which color and which size should I get? Apple's marketing division is definitely very good, so we can learn a lot from the way that they present their products on the website. And this is one of the perfect use cases for smooth animations, as we saw with the videos, and also perfect use case for showing up those 3D models. There aren't a lot of 3D websites, but if there is one that really should use 3D, it's the one where you can show the products in all of their full glory. And now that you have done all of this, created a 3D model as well as these playing videos and a nice looking header, when building websites as phenomenal as these ones right here, there's something that we often overlook, and that is performance, right? You're gonna say, why should I care about performance when my websites look like this? That's the most common thing we think about as developers, right? But still, no matter what you put into it, they still have to be performant and quick. Not to mention that the design should never take away from the form. You need to be able to figure out if the business objectives of the website are properly achieved, such as, is this titanium iPhone taking away from the screen? And are people actually clicking the buy button? So today, I wanted to take this video a step further and allow you to get answers to all of those questions. And learning this matters. It matters a lot. Let me give you a comparison of two resumes featuring projects from different developers. Take a moment to read through them and let me know which one sounds more impressive. The first one just built a website that looks like the iPhone 15 Pro page from Apple and used React, Three.js, and GSAP. Cool, right? But the second developer developed that website as well as tracked the number of visitors and how they're actually browsing the site. Are they taking the necessary actions that we want them to take? The second developer, they're also tracking performance, loading speeds, click-through rates, and all of that good stuff. So let's be real. Which developer will get a job? Well, it's gonna be the one with business metrics and performance optimizations. So for that reason, in this video, even though you might not have expected it, I want to teach you not just how to build and deploy a website, rather teach you how to get answers to all of those hard questions. And we'll do that using a completely free tool called Sentry, which will give us access to all of this information and more. It's super simple to integrate. So click the special link in the description so you can follow along and see exactly what I'm seeing, and then click Try Sentry for free. Create your account by signing up with Google or GitHub, and after you sign up, you'll be able to answer a couple of questions, such as your organization's name. If you have a company or if you work within a company, enter their name. If not, simply type JSM. Click I agree to terms and services, and you can choose whether you want to get email updates. Let's continue. And now let's follow the onboarding. We can install Sentry by clicking Start, and we'll choose the platform we want to monitor. In this case, it will be browser, and how handy it is, they also have a React wrapper. Press Configure SDK, and we can follow the steps provided right here. Let me zoom it in a bit. And first things first, we want to install Sentry as a dependency. So let's copy this command, open up our terminal, paste it, and press Enter. Then we can configure our SDK by copying this entire block of code and heading over to our main.jsx. Here is where we can paste what we copied, the setup for Sentry. We'll modify it just a tiny bit by removing this root render, as we already have that right here, and we're gonna keep the most important stuff right here that we copied. It seems like a lot, but you can also just remove the comments, and then you'll be able to see that there's basically a couple of specific properties that we are applying right here to customize the way that we want to track our application. There we go. This is it. Next, we have to upload our source maps, which allow us to track the traces for errors. Trust me, you're going to be pretty amazed at what this does. So let's copy it. Let's install it, as we have done that before. And to verify, we can render this somewhere by returning this button. Here, we get asked to install the Sentry wizard, so let's press Y, and you'll be asked to select what you want to do. We can choose yes or no. In this case, it says you're not within a GitHub repository. The wizard will create and update files. Do you want to continue anyway? I'm going to select yes. Are you using Sentry SaaS or self-hosted? We'll be using Sentry SaaS. Do you already have a Sentry account? Yes, we have just created it before. The wizard will verify that. And you can select your Sentry project and choose your framework. I'm going to choose Vite. And just like that, it's gonna install the Sentry Vite plugin without you having to do anything. It's gonna ask you if you're using CI/CD tool to build your application. We're gonna say yes. And we're gonna say yes, continue. That's it. We have successfully set up Sentry for our project. Now that that got installed, let's modify our integrations right here. Right now, we're using the browser tracing integration, but we also want to add Sentry.metrics aggregator integration like this. And we also want to add a Sentry.react router v6 browser tracing integration, to which we can pass an object and say useEffect is equal to react.useEffect. This way, it just knows that we're using React and how useEffects work. Finally, we want to update our app.jsx to wrap the app with Sentry. So let's navigate over to app. We're going to import everything as Sentry from @Sentry/React. And then we can simply wrap our app by saying Sentry dot with profiler, and then we wrap the app we have. Believe it or not, that's it. That's the entire setup. So right now it says this snippet contains an intentional error and can be used as a test to make sure that everything is working as expected. So let's simply copy this return, and instead of returning this entire main, let's try to simply return that button that contains a method that doesn't exist. I'm gonna save it and run our application by running npm run dev and opening it on localhost 5173. Immediately, you can see break the world. So now, if you click view sample error, it's gonna process that sample event, and it will give us all the information about the event that happened. Type error, object has no update from. Interesting. This one doesn't belong to our app, but soon enough, we'll configure Sentry to start viewing real errors. So let's break our app. This break the world is actually a button which you can click, and it contains a method that doesn't exist within our application. So if you inspect it and go to the console, you can see, if I make this the normal size, that it's gonna say uncaught reference error, method does not exist, is not defined. So we really are breaking the world. So once you do that, Sentry should have gotten that event and should enable our account. So now, if we go to issues, you can see that we have our reference error, method does not exist, is not defined. Sentry will automatically group similar events together into an issue. So let's click got it, and we can go into it and see more information about that issue. A pretty crazy thing about this is that you can see the browser, the operating system, as well as so much more information about that user, their IP address, the URL, and more. We can also mark it as handled or not handled. We can also see which function triggered it, and we can see full breadcrumbs of how this error came to be, all within this Sentry interface and not within our application. So imagine if you gave your app to the users, and if they noticed an error, it will be almost impossible to debug. They would send you screenshots, pieces of code, and so much more. But with this, you know exactly what is happening. And believe it or not, you can also see a replay of what the user was doing when the error happened. You can do that by going to replays, and you might need to wait a bit or reload to ensure that it actually shows up. But check this out. We have most dead clicks, which means clicks that don't do anything, and I did click on that button 4 times. We have rage clicks as well, because I was clicking on it and nothing was happening, so I was raging a bit, guilty as charged. And then we do have a full recording of the duration with everything that was happening. Let's click into it and check it out. If I click play, we can see the entire screen of exactly what I was doing on the screen and when I clicked it, as well as when the specific errors were happening. How crazy is that? I was also messing with my desktop and mobile view, so we can see that as well. And you can see exactly what's happening right here on the timeline. Pretty cool stuff. But of course, the most important thing we're concerned with is the errors tab, where you can click it, see the exact event ID, and see all the information about the error that happened so that we can resolve it. And to resolve this error, we can also scroll down a bit and see more information. You can see that the session replay, since now it has been rendered, actually appears right here within that specific error, so you don't even have to go to the replays. And then we have the complete breadcrumb of the error, as we have seen before, and everything about the user's device, browser, and more. And if you scroll a bit up, you'll be able to see this resources and maybe solutions. I like how at least they are being realistic with AI. Sometimes you might get lucky, but again, maybe not. So what we can do is we can click view suggestion, and their AI will, of course, if you give it consent, try to solve the error for you. And hey, it looks like you've encountered a reference error in your JavaScript code, which we did. So to fix this issue, you'll need to define the method does not exist in your code by adding it right here. And they give you some more tips for debugging it. In this case, instead of actually declaring it, we know that this is faulty code, which we don't need. So for now, I'm going to simply remove it from here, and that will fix the error. So I'm going to say, yes, this was surprisingly helpful. Now, let's see if the error has truly been fixed by going back to our app and reloading the screen. Yes, we have our titanium video, we have our highlight section, and we have our iPhone model right here. Looks great. But we're not here just to fix errors. Let's explore the performance tab. For you, it might say 0. It does take a minute or two to load, but very quickly, you should be able to see 100 here. I mean, our website is loading incredibly fast. We can see that the timing is incredibly low, and we can also head over to Web Vitals, and we can see the largest contentful paint within 300 milliseconds, which is good, and you get more information about everything that is happening on your app. I mean, how cool is this, and how convenient it is to have all of this in one place. We can also go to resources, where you can track exactly what your website is transferring over to the devices of different clients. The main JSX is the main thing we're transferring now, as well as some assets and images. Next, let's scroll down a bit and check the Discover tab. Here, you can discover different trends for your application. Like, we can bring it to the last hour, and you can see exactly when your users were doing what, which is quite exciting. So here you can see that one user had an error, and there was a transaction for the other user. Then you can track and see exactly what they're doing, from what browser family, what device, and so much more. It is all here, as we have explored before, and you can also see complete network events for everything they were doing on the site. Next, let's check out the dashboard. You can choose from different templates that you can use, like the front-end template, which shows you the erroring URLs and web vitals, or you can just check out the general one. So let's see the general. And here you can see the number of errors, the number of issues, the number of affected users, which is interesting, the handled versus unhandled errors. You can see this one is now counted as handled because we have fixed the error. You can see the errors by browser, so you know where everything is failing. Overall user misery is also a very interesting metric to track, I guess. And I mean, all of this is working so well for tracking what's happening on your application. Now, let me go back and let's see if I can get some more information from the front-end template by adding it to my dashboard. And here, if I zoom out just a tiny bit, you can see more information about the overall LCP, FCP, layout shifts happening, page load times, and more. So you can see the top 5 issues by unique users, URLs where the issues are happening, and if you have any slow page navigations. Of course, you can customize this by adding more widgets for duration, throughput, crash rates, health, and so much more. Even LCP by country, which is good to know if you have users from different countries. So I hope you liked this little intro to Sentry and how we can use it within our project. Now, as we continue developing our project, we'll be able to come back to it and see if it has recognized some new errors or if our app's performance dropped as we introduce some new animations. So we'll be able to track it all in real time. And you'll see me use Sentry in many more videos in the future. I recently found out about it, and I'm gonna use it for all of my apps, including our official course platform. Here, there's a lot of things that could go wrong just due to the sheer amount of features we're implementing within this project. People that have purchased the Ultimate Next.js course have access to this platform, and we want to ensure that nothing goes wrong. On the platform, we have a lot of custom stuff, like custom code blocks which you can copy, all the way to complete files, complete configurations, hints, images, and a lot more stuff like these callouts right here so you don't forget stuff. So if you're watching this video for building a GSAP and Three.js React application, you're gonna love what we do in the Ultimate Next.js 14 course. So check it out and you'll be able to access it within our new platform. And getting back to Sentry, as I said, you'll see me using their software in many of the upcoming videos, and we're gonna dive deeper into things like profiling, user feedback that allows your users to quickly add a bug report, cron actions, alerts, and so much more. While my goal is to teach you how to build beautiful websites, with this, I wanna take you a step further and also teach you how to make them make sense from a business as well as a marketing and maybe even performance optimization side of things. So with that in mind, let's focus on the next section of the day, which is going to be this one, where you can explore the full story of how iPhone gets made with this video and some new images appearing. And of course, if you continue scrolling down, more text and then these images animate back in. So with that in mind, let's get started working on the next section by pulling this to the side and adding the next section right here within our app.jsx. To get started with our next section, we can create a new component within the components folder called features.jsx. We can run RAFCE right within it, and then we can navigate over right here, imported features coming from features, and that's an automatic import from /components/features. Now, if we go back to our website, you should be able to see features right here at the bottom, which means that we can dive right into the features and start implementing it. First things first, we're going to turn this into a section with a class name equal to hfull for full height and common-padding. We're going to also give it a BG of zinc as well as relative and overflow-hidden. Now you can see features has its own space right here. Let's also create a div right here with a class name equal to screen-max-width. Within it, we'll have a div with a class name equal to margin bottom of 12 and w-full. And right within it, we're going to have an h1, which will have an ID equal to, we can do features underscore title, so we know what it is, and you know why we're adding it. That is because we want to animate it. Let's also give it a class name equal to section-heading, and it can say something like explore the full story. Dramatic as Apple usually likes to do it. So now we can add that first animation. If we scroll up and say use GSAP, coming from GSAP React. Now, you know how we used the use GSAP before. You provide a callback function right here, and then you also add a dependency array. Now, in this case, I want to teach you how to make this just a bit more optimized, and we want to use a dry principle of good code architecture, which means don't repeat yourself. Now, whenever we use the use GSAP, which you can see it's a couple of times so far, Typically, we use GSAP.to and then specify what we want to happen. And in these cases, we didn't have to use the scroll trigger, but sometimes we did. So if you see scroll trigger, we used it in the video carousel right here, where we have this use GSAP.to with the trigger video and then toggle actions. Now, every time that we want to use a specific scroll trigger, we need to repeat this part. Trigger is video, toggle actions is restart, none, none, and so on. So wouldn't it be better if we extracted this function call, where we repeat some stuff, to a new function within our animations.js file? We already have this animate with GSAP timeline, but right here above it, we can create a new export const animate with GSAP, which is equal to, we get the target, which we want to animate, the animation props, such as, opacity 1, and then also scroll props. And here, we're going to call the basic GSAP.to property. Of course, GSAP has to be imported from GSAP. Which target do we animate? Well, we already have it under target. And then what are the animation props, such as opacity 1, right? In this case, we can just spread all of the animation props coming from the props. And then we can also add this scroll trigger that I talked about, where the trigger will always be equal to the target, in our case at least. And then we also have these so-called toggle actions. And what toggle actions are is they determine how the length animation is controlled at 4 different places. On enter, so when we first enter it, we want to restart the animation. Then on leave, once we leave this specific target, then we want to reverse the animation. So this is interesting, reverse. Then when we enter back to it, we want to restart. And then when we leave back, we want to do reverse. So this toggle action figures out what will happen with this specific animation on 4 different distinct places. Whenever we scroll in, when we come back, when we scroll down and scroll up once again. Within here, we can also define the starting position of the scroll trigger, something like top 85%. That means that when the top of the trigger is 85% from the top of the viewport, it's going to activate, giving us enough space and time to trigger the animation. And we can also spread the rest of the scroll props. Great. So now we have this animate with GSAP function with scroll triggers. And now we can go back, not here, but rather in the features, and call animate with GSAP. And the only thing we have to do right now is provide the target. And in this case, the title is the ID of the H1, so features underscore title. And then we need to specify the Y is 0 and opacity is 1. So basically, we're simply saying, what do we want to animate? And now if we scroll down, we cannot see anything yet. And that's because I forgot to provide the hash to indicate that it's an ID. So now if I reload, oh, nothing is happening yet. The ID seems to be correct. And animate with GSAP indeed provides the GSAP2 functionality. Oh yeah, but for scroll triggers to work, we also need to register a scroll trigger plugin. And you do that by importing the scroll trigger coming from GSAP all, and then you say gsap.register plugin. And you simply pass that specific plugin you want to register. This is how you use plugins within GSAP. So now if I reload, that is how you use plugins within GSAP. And the reason why we might not be able to see the animation yet is because we cannot scroll to the top of it. So we need to keep adding some more stuff. So once we scroll down, we'll be able to see it. So let's go back to features. Below this H1 and below another div, we'll create a second div with a class name equal to flex, flex-call for column, justify-center, items-center, and overflow-hidden, so we don't see any scroll bars. Within it, we can create another div which will help us position the title within it by giving it a class name equal to margin top of 32, margin bottom of 24, and padding left of 24 too. Within there, we can simply say H2. That's going to say iPhone. And that iPhone you can see here. So let's style it a bit by giving it a class name equal to text-5XL. That's very big. As well as on large devices, text-7XL, which is even bigger, and font-semi-bold. There we go, iPhone. Let's also duplicate this below and say forged in titanium. As here, we want to show what it is made out of. There we go, iPhone forged in titanium. And now you can also see the explore the full story appear because we scrolled nicely there. Let's also go below this H2 and below another div, and then create another div, inside of which we'll show our animated videos and images. Let's give it a class name equal to flex-center, flex-call. On small devices, padding X of 10. Then we can give it a div inside of it, which will help us position these elements by giving it a class name of relative, h-50 view height, so that's 50% of the screen, w full for full width, flex, and items-center. Finally, within here, we want to display the video. So we can say video with a source that will have an src of explore video coming from utils and a type of video MP4. If we scroll down, we can see something that appears to be a non-playing video. So let's give it a property of plays in line. Let's give it an ID of explore video. Let's give it a class name of w-full for full width, h-full for full height, object-cover, as well as object-center. We can also give it a preload of none, so it doesn't take away from the website's performance. We will play it muted, and we will autoplay it. And we can also give it a ref to later on play with its settings. So at the top, we can create a new ref. Const video ref is equal to use ref coming from React. And we can pass that video ref right here. And there we go. As you can see, it started playing. Now, what's going to happen when it ends? It just stops. But later on, we want to make sure that we animate it in and out once we go up and down. Before we do that, let's also render the other two images, which we will animate. So we can go below this video and below another div, and then create a container for our images by saying div will have a class name equal to flex, flex-call, w-full, and relative. Within it, we can create another div, which will have a class name equal to feature-video-container. And within it, we can have another div that will contain one specific image. So it will have a class name equal to overflow-hidden, flex-1, and h-50vh. Within it, we can render a self-closing image tag that will have a source equal to explore1img, an alt tag of something like titanium, and a class name equal to feature-video g_grow. We'll use this to target this and give it some animations. So now let's duplicate this entire div containing the image, and let's make the second one render the explore2img, which we have to import, say titanium2, and I think this is it. If we save it and reload, we thought that we might be able to see those images, but there's nothing yet. And that's because they're hidden. So let's go ahead and animate them in. We can scroll up and we can reuse this same animate with GSAP function. where we can provide a new target of dot g underscore grow, and then we can expand it so it's easier to see which props are we passing. And we can also give it the animation props, such as scale of 1, so it's going to get bigger, opacity of 1, and ease of power 1. So this is the way that it actually animates. We can also give it some scroll properties, and in this case, I'm going to use scrub of 5.5. I found this value to work the best. And as soon as you save the file, you can see those two images appear. They go out and they come back in. Wonderful. Now, let's scroll a bit more down. And let's also add some text below those images. So let's find the last image, go 1, 2 divs below, and create a final div container that will have a class name equal to feature-text-container. Inside of it, we can create another div that will have a class name equal to flex-1 and flex-center. And within it, we can have a piece of text, a p tag, that has a class name equal to feature-text, as well as g underscore text, because we'll animate it as well. So this g underscore stands for GSAP. And here we can say iPhone 15 Pro is, and then we can leave a space like so, and save it. You cannot see anything yet because we didn't animate it in. But at the end, it should look something like this. There we go. iPhone 15 Pro is, and then we want to create a span for the rest of the text. So let's do that. Right below, we can create a span element with a class name equal to text-white. And then you can follow along and type with me. I'm going to say the first iPhone to feature an aerospace grade titanium design using the same alloy that spacecrafts use for missions to Mars. Okay, let's go back. We still cannot see it, so now might be a good idea to animate that in. So if we scroll right here below this animate with GSAP, we can add a new one and say animate with GSAP. What do we want to animate? In this case, it will be a .g underscore text. You see how easy it is once you have a function you can reuse. Then you provide specific properties you want to animate, such as y of 0, opacity of 1. We can also do an ease of power 2 dot in out and a duration of 1. Of course, this has to be within an object, so let's fix it. There we go. And that is it. So now if you reload, you can see that the text appears right below. Let's fix this. It's an iPhone. And now if I reload, it's not there. That's because we have to scroll a bit more to see it. Don't worry, we'll do that soon. Let's just go below this div and then duplicate this entire div with flex1 and flex center for the second piece of text. There we go. Now you can see it. But of course, we have to say something different now. So in this case, I will say something like, let's do titanium has one of the best strength to weight ratios of any metal, making these our, and here we can say lightest Pro models ever. Apple surely does know how to market it. And here we can say you'll notice the difference the moment you pick one up. There we go. So now we have this nice piece of text right here, looking great. So now this entire section is looking good. The images are indeed animating in. The text comes in as well. But this video, once it continues playing, it's just stuck. So we have to play with it a bit more to make it come to life. Let's scroll up. And what do you say that we try using this animate with GSAP? So we can say animate with GSAP, where we can provide the hash explore video and save it. Now, if you reload, it starts playing. It looks great. There we go, it animates. But if you scroll up or down, still nothing happens. So let's go to animate with GSAP. Let's copy this entire GSAP.2. And for this one, let's apply a manual animation without using a reusable function because it will be just a bit different. So the target will be the explore video, of course, with the hash at the start. We don't need to pass any animation props. The scroll trigger will also be explore video, and the actions will be a bit different because we're dealing with the video. So it's going to be play, pause if we go away, and then reverse, restart. You can play with these toggle actions a bit more and see how they behave. Finally, the start will be minus 10% at the bottom. And finally, the third property will be onComplete. So what happens once it is complete? And here we want to say video.play. So essentially, we will just restart the play. And of course, here we also have to import GSAP from GSAP. And now we can scroll down. You can see that the video plays, the images animate, and once it comes to the end, if we go out and come back again, nothing happens. And that's because this video.play right here is not referring to anything. Rather, it should be saying videoref.current.play because that's how we're targeting this video. So now, as you can see, it's playing, and once it finishes, if I scroll up or down, it will start playing once again. Great. Now let's expand our browser and check this out. Right here, after you see this great looking model, you scroll down and you're greeted with explore the full story. Of the iPhone forged in titanium, we have this great looking video and two images that give you more detail. Now, if you scroll down, you see some pieces of text. And if you scroll up, nothing happens to the video, but if you go once again down, it starts playing again. It's just a small little detail, and of course, you have a bit of creative freedom to figure out how you want to play with these animations by choosing when you want to trigger them. You can trigger them on click or on scroll or in many different situations. With that in mind, our phenomenal feature section has now been completed. It's been a bit easier than the last two, right? Well, that's because now you know how to animate better, and let's be honest, it also was a bit easier to implement than the last two. But now, let's move to the next one, which looks like this. A17 Pro chip, a monster for gaming. Looks like this. And on desktop devices, it looks like this. The chip animates in, and this great looking video starts playing. So, with that in mind, let's start doing that section next by going back to our development environment, closing everything besides the app, and creating a new component within the components folder called how it works, or you can also call it a chip. So I'm going to say how it works.jsx, run RAFCE, go back to the app, and render the how it works section, which of course we have to import from the components. How it works. And now at the bottom, there it is. We can come into it and start developing it. To get started working on our how it works section, we can first turn it into a section and give it a class name equal to common padding, as we typically do. Next, we want to also give it a max screen width, so we can create a new div and give it a class name equal to screen max width. Now, right within it, we can create a new div that will have an ID equal to chip. And yes, this will be our processor chip image. So we can give it a class name equal to flex-center, w-full, and margin y of 20. Within it, we can render the self-closing image tag. this image will have a source equal to chip image or chip img coming from utils, as well as an alt tag of chip and a width of about 180 and a height of about 180 as well. There we go, A17 Pro chip. Now, what do you say that we go ahead and animate it? So right at the top, we can use the use GSAP hook, and we can create a callback function and then an empty dependency array. Right here, we can say GSAP dot, and for the first time ever, we'll use the from property instead of to property because we're animating it from a specific position. So here, we can say what do we want to animate. It's going to be the ID of chip, and we have to import GSAP from GSAP. Here, we can give it some scroll properties by saying scroll trigger, and the trigger will be the actual chip, so once we reach it, and we're going to start on about 20% from the bottom. And we want to animate from opacity of 0, scale of 2, duration of 2 as well, and ease of power 2 dot in out. Now, if we save it, you can see it's gone and then it comes in. As simple as that. Let's reload that and see it one more time. There we go. That's looking great. Now let's go below the chip and below the div and create another div with a class name equal to flex, flex-call, items-center, and right within it, we can create a new h2 property with a class name equal to HIW, which means how it works, title, like this, and we can say something like, let's do A17 Pro chip, like this, and then we can add a break tag, and then say a monster when for gaming. So now you can apparently game on your phone as well. Below it, we want to have a p tag with a class name equal to HIW subtitle, and here we can say it's here, the biggest redesign in the history of Apple GPUs. And save. There we go. That's more like it. Now below it, we want to show that huge video which will be playing right here. So let's scroll down. Let's go below the p tag and below one more div and create a container for our video player. We can do that by saying div with a class name equal to margin top of 10, on medium devices margin top of 20, and a margin bottom of 14. Within it, we can give it a div with a class name equal to relative, h-full for full height, and a flex-center. Within it, we can have one last div with a class name equal to overflow-hidden. And within it, we can render the image. So this will be a self-closing image with a source equal to frame img coming from utils, an alt tag of frame, and a class name equal to bg-transparent, relative, and z of 10. So now if we save it, you can see this iPhone looking frame. We want to place the video right within it. So right below this image, we can have another div with a class name equal to HIW video, and right within it, we can create a new video property with a source of src frame video and a type of video MP4. Now it appears at the bottom of it, but let's style it up. Now currently it appears at the bottom of it, and that's because we should have put it below this div closing the image. So here we have the image, and then we go one div down and then paste it right here. Now it fits perfectly within the image. Let's also style this video property by giving it a class name equal to pointer-events-none. Let's give it a plays inline, a preload of none, a muted property, autoplay, and we can also give it a ref equal to video ref, which we need to, of course, create at the top by saying const video ref is equal to use ref coming from React, which we, of course, have to import. Now, if we save that, you can see that the video starts autoplaying. Of course, we'll kind of animate it so that it looks better even on larger devices. Now we want to add a bit of text at the bottom, so we can scroll below the video and then below 2 more divs. And here we want to do a p tag that says Honkai Star Rail. This is apparently a very good game that runs on this specific chip. We can style it by giving it a class name of text-gray, font-semi-bold, text-center, and a margin top of 3 to divide it a bit from the phone. Now, right below it, we want to have a couple of pieces of text that nicely slides in. And this text is quite similar to the text that we had in the previous section. So let's go to the app, go to features, and let's just copy these 2 pieces of text. There we go, div text container. As a matter of fact, we can copy the entire text container from here to here, and then paste it right within how it works below this p tag. Now, if we save it and go back, you won't be able to see it yet because it's hidden by default. So let's style it a bit. Instead of saying feature text container, we can rename it to HIW, which means how it works, text container. Then it can have a property of flex, flex-1, and in this case, we can do justify center and flex-call. Next, instead of feature text, we can have an HIW text. There we go. And we can call it G fade in because we want to fade this text in. And here we can say something like A17 Pro is an entirely new class of iPhone chip that delivers our space, and then in white we can say something like best graphic performance by far. We can delete this thing after the span, and then we have the second div, which we can remove and just have a p tag that says HIW text. We can say something like mobile. Within the span, games will look and feel so immersive. And then after the span, we can say something like with incredibly detailed environments and characters. Now, if we save it, you can see this text right here, but we cannot yet see this one. That's because this one also has to say fade in, and then both will be gone, and we'll be able to animate them once we scroll in. Before we do that, let's also add this one, new Pro class GPU with 6 cores. That's going to be below this div containing the p tag. It's going to be a special div with a class name equal to flex-1, flex, justify-center, flex-call, and g_fade in as well. Within it, we can have a p tag that will say something like new, and it will have a class name equal to HIW text. Now we can duplicate this 2 more times. The second one will say Pro class GPU, and the third one will say with 6 cores. Now if I save it, we cannot yet see it because it also will fade in, and the middle one will have a class name of big text because we want it to appear like this. So now let's go ahead and fade those in. We can do that by scrolling up, going below this GSAP from, and calling our reusable function animate with GSAP. We want to animate anything with a class of G, fade in. Make sure to add a dot at the start as it's a class. And then we can provide opacity of 1, Y position of 0, duration of 1, and ease of power 2 dot in out. If we save it, you can see all of these nicely scroll in. Now it looks like this is not properly positioned, so let's position it properly. If we scroll down, you'll notice that we have this div closing the video, and then one more div which closes this video context. And then below it, we have the Honkai Star rail. But what needed to happen here is we need to close this previous div. So here we close another div, and then right below at the end, we can remove one closing sign. This will now properly position it. Also, looking at this part at the bottom, it seems like it's too close to what we have at the top. So let's see if it's in the right container. We have this HIW text container, and it looks like I ended it a bit too soon. It should have been ended right here at the bottom. So if I fix this, now this looks better. So let's expand it to see it on full screen. I'm gonna scroll up and reload, and now I'm gonna smoothly scroll down. You see the chip animate, you see this video play, looks much better on the big screen, and then we have the text right here. Oh, let's see if this text is looking good. It looks like the positioning is a bit off. As you can see right here, it looks like we didn't properly close these two first pieces of text together. So let's do that by taking a look at this one, and then we have to close it right below this p tag. Now, if we do that, you can see it looks great. We cannot get to the second piece of text because we don't have the footer yet, but we will soon, and it will look like this. So with that in mind, let's quickly get the footer going as well. It'll be quite simple. We just have to go to the components and create a new footer.jsx component where we can run rafce, and we can just render this footer right here. Of course, it has to be imported at the top, footer coming from footer. There it is at the bottom left. We can dive into it, and we can develop it by enclosing it within an HTML5 footer property with a class name equal to padding y of 5 on small devices, padding x of 10, and usually padding x of 5 as well. Let's also bring this back to the mobile view so we can see what's happening. Within this footer, we can have another div for the max screen width by saying class name is equal to screen-max-width. Within it, we can have another div for our first part of the footer. Within it, we can have a p tag that will say more ways to shop. There we go, more ways to shop. Let's style it a bit by giving it a class name of font-semi-bold, text-gray, and text-xs for extra small. Then within this p tag, we can have a span that will have a class name equal to underline and text-blue to signify it's a link. We can add a space beforehand and say find an Apple store. We can also add a space, exit the span, so that looks like this right now. And this space can be outside, so it doesn't get an underline right here. There we go. And then out of the span, we can say or, and then once again within this same span, so we can simply copy it and paste it, we can say other retailer, and then exit out of the span near you. There we go. So this looks good. We need to provide some spacing. So after or and after the span, some space. We can go here and duplicate this p tag one more time, right below the first one, and properly close it. And here we can say something like or call, and then we can do some kind of a phone number. I'm just going to type some random stuff right here. There we go. This looks good to me. Now we want to go below this p tag and below this div and create just a self-closing div, which will act as a divider line by giving it a class name of bg neutral of 700, margin y of 5, h-1 pixel, and w-full. This will give us a nice divider line, and right below it, we can show all of the footer links. So to do that, we can just say div with a class name equal to flex, on medium devices, flex-row, flex-column on smaller devices, on medium devices, items-center, and justify-between. Within it, we can have a p tag that will have the same class name as the one above. So we can copy that class name, font semi-bold, text gray, and text XS, and we can say something like copyright 2024 Apple Incorporated, all rights reserved. There we go. And finally, we can have a div below this p tag with a class name of flex. And here we can map over our footer links. So footer links coming from constants dot map, where we get each individual link, and for each one we can return a p tag with a key equal to link, same class name once again as the previous one, and within it we can render a link and then a space after the link that will look like this, and you have all of the links right here. Now you can notice that after some we don't have space, so we can say if I is not equal to footer links dot length -1, so if it's not the last one, then also add a span with a class name of margin x of 2, so mx2, and add a straight line like this. And this will create some spacing, but of course make sure that you're properly closing everything. And in this case, we also have to get the index as we're mapping over it. And now if we scroll down, you can see this great looking footer. And of course, you can turn these into links once you actually have somewhere to navigate. And with that said, our footer is done. But it's not just the footer. It's our entire GSAP, Three.js, and Sentry-powered website. And now is the time that we deploy it. It's time to share this wonderful looking hero section that animates in, this highlight section which we worked so hard on, this great looking Three.js modal section, as well as the explore the full story and materials, the chipset, and even the footer. It's time to get it all deployed and on the internet so you can share it with everyone. To start deploying our Apple website, head over to your Hostinger's dashboard, find the project, and head to its file manager. Now you can go into the public HTML and remove this default PHP by deleting it. Then we'll be able to upload our entire codebase. So back within our Visual Studio Code, you can stop our terminal from running by pressing Ctrl+C and then clear it. Next, head over to package.json, and within here, we can see that the build script is npm run build. So let's type npm run build, which will run an optimized production build of our application. There we go. In about 8 seconds, it is done. So now, if you close this up and head to the File Explorer, if you collapse it, you'll be able to see a new dist folder appear, which, if you right-click, you can reveal in Finder or open in File Explorer. Once you open it, you can go into it, copy all of the files, and simply drag and drop them within this empty folder on our H panel. This should take just about a minute, maybe even less. And as soon as it is done, we can go back to our specific project's dashboard and click our chosen domain name. Just like that, our project is now deployed and live on the internet. It took less than a minute. Now we can scroll through it and admire it in its full glory with this phenomenal highlight section. Not to mention that we also have this great looking Apple iPhone logo and the Apple iPhone title, and our domain is HTTPS secured. Let's continue scrolling down a bit to take a closer look at our 3D model. This is looking phenomenal. Let's not forget that we can also change the colors, which are immediately reflected right here. And let's see how GSAP and Three.js work together by animating this model. There we go. That's more like it. Now let's continue and see this section where we can see this titanium in more detail, learn more about the A17 Pro chip, and then see the footer with all the links. Of course, let's not forget that the entire project is completely mobile responsive. So if I open up my inspect element and collapse this just a bit, you can see how in mobile we get a completely different view with the highlight section videos appearing like this, 3D model looking like this, and all of the other sections seamlessly fitting into the view. Wonderful. So with that in mind, huge thanks to you for coming to the end of this video, and congratulations. Be proud of yourself that you built something like this. And if you liked what we were building here, you will love what we do on JSMastery.pro, specifically our ultimate Next.js 14 course. I can proudly say that it is the best course out there to make you the top 1 Next.js developer. We follow what the best companies in the world are doing and how they're using Next.js. They're not using it like good old React, because then they would fall into a trap of using the client side on everything and having bad performance, accessibility, and SEO. Thankfully, I'm gonna teach you how to use it like a real pro. We'll do a deep down to fully understand how it works behind the scenes. Then we'll build and deploy a very complex app, and you'll also get a chance to participate in active lessons where we give you complete hints, and then you have to build a specific feature. Everything from task to examples, think, resources, and even hints on developing something so you can truly understand what you're doing. And of course, you're gonna build one of the best apps out there, a modern version of Stack Overflow. So with that said, what are you waiting for? Go to jsmastery.pro and check out our ultimate Next.js 14 course. I'll see you there.